All right, hello, welcome everybody. Come on in. I know the keynote just finished, so if you're kind of making your way in, we're gonna get started. So, hey everybody, hopefully you enjoyed the keynote. We're live on the internet, so say hello. I'm Andy Blondin from Epic Games. I'm a technical product manager here at Epic. And today I have the great pleasure to share with you some of the advancements that we're doing with the Unreal Motion Design tool set. And so the talk is titled Cutting Edge Tools and Techniques. How many of you have seen our new motion design tools in 5.4? Yeah? Awesome, awesome. So I have a great product update for you to kind of showcase some of the work that we've been up to. So what is motion design? It's a suite of tools that we built into the Unreal Engine, so it's not just a one particular tool. It's a whole host and a mode that gives you access to cloners and effectors and animators, but really at the core of it, it focuses on artist-friendly workflows. So a lot of you are producing content for television, for social media, for marketing, and sometimes going through that process can be difficult. So in our case, we built a little bit of thing through the beta community. Some of our members kicked out some really cool stuff for the 5.4 release. So Harold Hernandez put up together a nice little shoe commercial for us and some of the things that you'd be able to see watching kind of network television. And so today we're going to go over some of the examples that we've seen from the community. And one of the coolest examples I saw that really got me excited was Arthur Baum put together this little short film called Industria that I was kind of blown away with. As a product manager, sometimes your artists make things that you just didn't even know were possible. Well, this was one of those moments for me. And so I want to share this short film with you that he made with one of the features that we call cloners and effectors. And go ahead, it's kind of dark and moody. Enjoy the sound. And yeah, we'll kick it off. So yeah, really awesome piece of content there. Congrats to the team that put that together. But showcase some of the powerful tools, like we've been, go back one more, with things like our cloners and effectors. Go ahead and click play on that, sorry. I'll just click from here, sorry about that, guys. So we have features like cloners and effectors, and this is what it's like as an artist to be able to work in the viewport. So these are tools that we've built that allow you to clone and replicate geometry. We'll be covering these in great detail today. But as an artist, it's super freeing to be able to play with this level of control and rendering in real time. So this is from Wallace David, who put together a really cool, kind of pseudo athletic wear ad where you can reveal on through all these threads and cloners and effectors. So very powerful to be able to do these things in real time, which is something that was always difficult before this to date. So next up, I want to show an example, and this is in our 5.4 era, but from our esports company we work with called Blast, and they're responsible for putting on the esports content and events, and so they built and prevised kind of the walk-ups for the last Rocket League championships. And so this kind of tells the story of being able to design, previs things, do all the motion graphics that you see on the screens, and then play them out during the event. So this is a little example here. Just showcasing what that looks like in Engine. So they built all the different teams. There were 6 different teams with different shapes and designs, text, 3D graphics, and then synchronize that with the DMX lighting. And then when that gets broken down and put onto the LED monitors, it looks a little bit like this. So you have the content there played out on all the different ribbon strips. And so with different shape tools that we have, they were able to, in Material Designer, which we'll be covering in detail, they made all the motion graphics for these 6 different teams in the walk-ups. And then you can see here, this is what it looks like, you know, when they actually go to do the event.
Number 1 seed, Gentle Mates.
So it kind of shows you all the way from design and iteration all the way through to, you know, playing them out live. We're trying to build a graphic system that would allow you to scale to, you know, full output onto big LED screens. So next up, yeah, just looking at some more of the beta content. Different team members were putting stuff together, and this was Ali 3D, who, you know, we saw a lot of these like really awesome procedural growth type effects coming out of the beta. And so with the cloners and effectors, these were things that the users are putting together here. So, you know, that ribbon type reveal, this was Wallace David kind of revealing a logo on. So we have the ability to take an image and then take that threading and be able to animate those. So as an art director in the past life, you know, these were the kind of things we'd be waiting 2 to 3 minutes per frame to see the results. This is an example from Nick here, Justician. So being able to do the HUD display and being able to do the reveal on effect comes from all of our cloner and effector tools. And then this is a little cartoony type example that you saw, but you can see it can be stylized too, but being able to take those shapes and geometry and to be able to replicate them into different shapes. So you can see here, this is our kind of how it works. If you're unfamiliar with cloners and effectors, is you get different patterns. You can do a grid or honeycomb, cylinder, spheres, and you can clone and replicate the geometry. So whatever you put inside of a cloner, it will start to replicate. And then you have noise patterns and procedural movement with effectors. And so effectors, you can basically, you know, add all these kind of cool motion. So each one of those is, you know, a 10,000 triangle mesh, and you can see it performs super well. So this is very, very liberating to be able to work this way and not have to wait for long renders anymore. But we can also add things like forces and effects, and you'll see in the 5.5 that we've taken this a lot further. So here's an example, you know, just showcasing using this kind of thing with Lumen, how quickly and easily you can build up a scene like this, and with the different lighting, it's just kind of magical to be able to, you know, in your viewport, see things that look path traced fully in real time. So a lot of fun kind of activity there. Next up, so what's new? What do you guys have in 5.5? Well, we were missing a couple things. With the cloners and effectors, we were missing this idea of proximity effects to be able to take, you know, the materials and make things glow, or to be able to add some of those properties. So each of the effectors now has the ability to take the color. In this case, I'm putting it into the emissive, and then you can make those items animate and transition between, you know, different materials. So you can see here, it's just fun to play with. And next up after this, you know, I'll show in the same way. We have some different shapes. Sometimes it's hard to achieve certain shapes, so there's more of a torus and disc style shapes that we have now. Inside that, you can see that we have circular kind of inner and outer fall-offs, but you can take that particle color that I was talking about and be able to target those specific regions. So now you can easily colorize much more of the effects that you could do, where it was difficult in the 5.4 era of things. And then we've added in the ability to kind of scale and transform those, so you can kind of squash and stretch these shapes. So it's very fun to be able to just duplicate and kind of put those all throughout your scene. There's even some like advanced modes here where you have fall-offs of like a 360 and can get different reveal effects that were kind of challenging to do in the 5.4 timeframe, are much easier to do now. Along with that, there's the idea of having like particle color and particle randomness. You can actually get the particle speed and the particle velocity to drive things. But in this case, I'm using a new effector that's called a push-apart effector. And with this, you can get much more of like a force field style effect. So you can see inside the sphere, it's pushing those away. And then outside, I have those particle effects colorizing. So it should be a lot more robust in some of the areas that you can target. One of the big ones that we've added for this release is the particle physics. So now you actually can put physics onto the different cloners and effectors. And you can see here, I'm just going to run through a bunch of different options. But you also get particle collisions between interparticles, but you can also get collisions with different meshes. As I move around the game controller, for example, you can see how those kind of sweep around that side. So it's very fun to be able to, it's kind of addicting to play with these tools. Another part is that you can actually cache these in to the sequencer now. So I'll share at the end of the session, but there's some utilities that are there that allow you to one button click, say you want to cache or add it to the sequencer tracks. So it's very fun to work with. We added in some twist and spiraling effects. So you probably saw this during the keynote here, but the little fake cell phone ad that we have here, but being able to animate the clone count now and animate the effects. I think I'm using a step effector in this case here. So you can kind of see as I hop out, what that looks like. And I'm animating the phones to twirl around. And then there's a twist effect that I'm applying. And with this, I just have a simple plane effector, and I'm being able to move that from left to right. That's changing the magnitude of the overall effect. So very kind of powerful to be able to add. Obviously, these are very common for different. So same thing, showing the combination of these here, but the twists and the different proximity effects, you can kind of build these up, but obviously trendy for hip modern motion graphics. So same thing here. Next up, I'll show you here. So this is an example that's closer to like a fake Fast and Furious movie or action trailer. You can see in the back there, I have a cloner and effector, and we have a new twist property that's on the grids and honeycomb. So I'm cloning like 10,000 particles here, and then have the ability to just twist and turn that into some kind of a spiral effect. And then you may notice that we have some new kind of text effects that are happening as well that I'm going to cover in more detail in just a second. So the material designer, that is another core tenet of the system that we're doing. Again, like you can see, we're not necessarily having to go into Blueprint or to make anything custom. We're trying to put as much of this into the UI as possible. So the material designer got quite an overhaul in many areas, so we're going to focus in on this for a bit. But you'll see here that we have a new kind of shader preview, and you have the ability to take what we call a texture set and just drag and drop a set of PBR textures, and it will detect what channels that should belong to based on the naming conventions. And you can, in a sense, kind of one button click, create a new PBR material. So we have channels for each of those. You have base color and emissive. You can toggle all of those on and off as you want, and you'll get a new channel to pop up. And then as you drag in these texture sets, I'm going to swap between a few of them here, but you'll see. So each channel is almost like a little mini Photoshop stack, and you have the ability to change the blend modes. You can add effects onto that, which we'll talk about in the next videos. But like I'll add a brightness and contrast to be able to control like the roughness, for example, here. And all the UVs and tiling is built right in, so you don't have to necessarily build your own custom things anymore. So you can see here, I'm just adding a surface imperfection map on top of that and being able to blend those, very quickly in real time. We've added a whole bunch of different effects into this, so it's not just brightness and contrast and that kind of thing. We've added things like Fresnel, and the particle glow that I was talking about is available in there. So we're starting to add more and more kind of procedural effects. And all of these effects are actually material functions. So if you're very good with Unreal shaders, with this system, you can build your own effects. And those effects in the project setting, you have a folder that you can point it toward, and it will read into that UI, and it will show up for the user. So you can see here, I'm just dragging and dropping a bunch of different textures in there and kind of showing you that, over the course of a few minutes, I'm able to make a whole host of new materials. You can save those out. Obviously here, save those as an instance, and then you can drag and drop. The nice part about the UI is as you click on the UI, you can see it's swapping to each material fully live. So you don't necessarily, so I like to dock the UI into different channels and kind of keep it there, but you can see as I run through here a little rip, kind of dragging and dropping all the different materials that I was able to create, in a few minutes. So hopefully this speeds you up on your workflow of just being able to treat it much more in that artist realm. We definitely want some feedback and would like to kind of keep going further. And this is where it gets interesting for you guys as well, is what if we can take video and push that through that system as well? So in the Material Designer, we now support media textures. So in the case, I'm taking a couple of media textures that I have inside of the sequencer there, and I have 4 different video clips that are playing fully in real time. So these are different kind of stock clips that I have, and being able to play those things, and I'll show you. But you can add white and black mask to be able to wipe between those, so it kind of fully supports having an alpha channel, and then you can see it, like changing the text and putting things on top. But there's no waiting times or no caching or rendering. You can just kind of drag and drop a new asset and be able to play that back. So these are Apple ProRes clips. In some cases, I'm playing 4K clips and some 1080. So it's a mix of how well your system will do based on your own kind of disk speed and requirements, but it's very optimized to be able to be playback, obviously, on the GPU. So in the case here, I have a little trendy title sequence, being able to move that down, reposition. The text effects that you're seeing in there as well is fully done inside Unreal. A little stop motion kind of stylization to it. And then you can move the title to reposition it so it lands on top of that logo, for example. So I think this is really going to unlock once we start to mix media between having video playback and having some of the 3D graphics that you guys are used to on top of that. So to talk more about those effects, those materials are effects that we just call, they're material functions. Any artist can make these. So we've provided a whole bunch of them, but in this case we have like halftone pattern, for example, and you can see how you can start to get very stylized looking footage out of this. So just playing around with the sliders is very cool. We've added a bunch of the coloring ones, a lot of the distortion ones for panning, scaling, UVs, and we have a few blurs that are in there, and we're looking to kind of expand. There are some limitations to it. Blurs are complex, so you have to feed the texture as a reference into the effect itself, but you can see, in this case here, this could be like a music concert visual, so just being able to build up those effects. So in this case, adding a glow effect on top of this, being able to add another texture layer. I'll go ahead and copy the media and give it the grungy kind of feel, and then being able to boom, play this back fully in real time. And then any of the layers can continue to build up those effects. So as I add like a tint and a glow on top of those, it inherits all those. So you can kind of imagine how you can quickly build up, really cool, complex video sequences with this. So we've added in some nice functions too here that will allow you to glitch and pan the UVs. So one thing that's common and trendy is just to have that, paper-like feel on top of the footage, stuff like that. So in this case, there's one that will take that and randomize the positioning so that you can get different motion. So we definitely want to work with you guys as a community to build up more of these effects and see where we can kind of take it, but it's more of an open-ended system. So in the last sequence here, I think just showing something that's more, again, concert visual style stuff, but the ability to, mirror this footage and kind of play it back. So again, if you didn't necessarily need everything to be, fully driven in real time, this also is going to provide you tons of power. So next up, after that is animators. We have procedural animation and presets. And inside of this, you'll see we have a system called animators that you can target any specific property. So if you come kind of maybe from the After Effects world, you might have expressions. This will allow you to, in a non kind of coding way, be able to add procedural motion to any property. So in this case, I'm taking the rotation and being able to have like a game controller on a loop spin like this. And you can see we have like it overshooting back and forth. So there's different sine waves and curves that allow you to, get various types of animation. But again, this is the kind of thing you might do in, other software that you'll be waiting in time, obviously, to render those frames. It's super freeing to be able to playfully change these properties fully live. So we even put in some, again, kind of stop motion feel. You can change like the frame rate. So if you needed a lo-fi kind of look to things, you can actually just sample and turn that to say like 8 frames per second there and get like a really cool look. So overall, it's going to be a lot of fun to see what you guys do with these new tools. Those can be added to Sequencer, and you can have the timing for when those trigger. So within Sequencer, there's tracks that allow you to fade. So you can fade in and out on this. So you can kind of see it's paused, and then as it goes in, it will fade in and out. So we're looking further out at more presets and how we can make that even more powerful. So there's less clicks, more artist friendly. And so that gets us into, this doesn't just apply to any property, but you can also do text. So text effects we know is super common need inside of any motion graphics. So you can see here we have a new thing that we are calling the curve animator that we want to work with you guys and keep going even further. But what it allows you to do is to take a curve and then apply those properties over. So in this case, I'm taking something that is like a jiggle style effect and allowing those to animate. So you can make a curve asset in Unreal, and you can load in any of the curves that you want. So you can get really dynamic kind of jiggle effects and have text scale up and that kind of thing. So in this example, I'm just taking like a bounce down from the top, and you can see here changing the timing of it. So each property, there's a timing offset, and if I adjust that timing offset, I get a very different look to it. So you can also save these as presets. So once you've defined the look and do that, you can save it out as a preset. And then you can stack multiple of these. So you can have an animator, like 2 or 3 animators touching the position property and the scale property, for example, on those. So I think it's going to be a really cool way for you guys to work as motion designers. And obviously, this can apply to not just text. We're trying to take it in some of the prior or next releases to like sub-properties. If you had many objects built up below a null, could we do those same kind of effects of rippling on through many objects, that kind of thing. So, just kind of showing you easy examples, but this kind of stuff comes up all the time, a little end tag, but those cascade style effects with emotion, for example, you can do quite easily. So next up, I want to talk about some of the broadcast workflows. This one's pretty specific to if you're a network broadcaster. So we have something called transition logic. And transition logic is, if you're a broadcaster, you need to take multiple things on the screen at the same time. So if I was giving this presentation, I could have my nameplate pop up. I could have the live bug come in. I could have the ticker come in. And so you need the ability to have multiple elements come onto the screen at the same time. And that's called transition logic. And In the 5.4 release, we had a version of it. It was pretty complex, if I'm being honest. So we spent a lot of time refocusing on more of the ease of use. So you can see here, just running through those different cycles, you can have multiple graphics on the screen at the same time. You can change the state of those graphics, so you could widen, some of those elements out. You can shift the graphics up when the ticker comes in, for example. And in this case, this shows you a little bit of how it's done, but we have an in and an out, and then each layer within the scene that we call sublayers has an in and out to it. And if you animate those on the timeline in the directors, when any change happens, it will go ahead and trigger just those elements to come in and out. So this idea of a sublayer, you can go ahead and select, a header. You could select the top line, the footnote, the ticker. And once you assign those, the beautiful thing, I think, is that these are all kept in one scene, and it manages the states. So you don't have to separate the scene out into many scenes. You can keep everything kind of built in one common scene, which makes things way easier for testing in this case. But we think it's going to be really, helpful for you guys. Next up, I'm just going to cover some of the masking things. So we're trying to make some masking things easier in Unreal. Transparency and other things have been a challenge inside of Game Engine. So, you can mask in multiple ways, but like here's a little example I had with a logo reveal that comes in, but we can use the textures, and then we have something else called a geometry mask. So in this case, believe it or not, this is an example just made out of 2 images. It's just a backplate of a warpy kind of element and putting some lens distortion in those effects layers and being able to keyframe those. But you can see the white and black mask that's there. Those can all be animated within the material designer. And you can, take something that was pretty static and make it super dynamic. So just 2 textures and a little particle system can offer you a lot of production value. So next up, these are I do little examples like this to kind of push the tech a bit, but you can see inside the word motion there, you have masking happening. And so, if this was a show kind of logo, I'm using some of the animators and the word motion as a text mask, and you can mask through to other shapes inside of that. Again, kind of another little show open, but you can kind of see inside the word motion as it reveals or masking and cutting through multiple layers of text. And so this shows you a little bit on the outside when you jump out of the scene, what it looks like, obviously, to kind of work in. And so, yeah, it's all fully built inside Unreal Engine as is today. And this one is a little Spideyverse vibe to it, but in the same way, taking our logo and having 4 or 5 copies of that, being able to mask and cut through those layers and reveal the text on. So this is using our geometry mask modifier. And if you're familiar with the After Effects world, you might have a couple white and black masks that you animate. So those are all geometric shapes that are animated through. So different things like this play the game. These type of examples are really good for just kind of stress testing more of those things. So there's a round of quality life enhancements from our beta channel. I know Sean's here and Nick's here, and they provide a lot of good feedback to me as a product manager. So we've made it easy to just go to any actor in the outliner, and you can right-click and create a cloner from that. You can also now create static meshes from those. So if you get a really cool effect going and you need to bake that down and create a static mesh from that. So it's helpful for things like world building, where you just want to be able to replicate a whole bunch of shapes and then unify them and merge them into one single object. It's really good for those type of things. I mentioned being able to utilize the cloners and effectors system. So we have a new material function that you have inside if you right-click in a material. But you can see here we can get the effectors, and we can get the count, we can get the randomness, the age of the particles. So you can use all of these properties now within the material system. So as an effector, you can feed some of those and use them. So the effects you saw earlier with proximity effects, I'm kind of using this system to colorize things. In the material designer, you saw those effects that we put. There's a new function in there. It's called particle color. So you can hook it up and start to drive some of these properties. And another one that's like small but meaningful is that cloners can now be cached as a Niagara track. So you have the ability to, there's a panel in there called utilities in every cloner at the end, and you can click on the button and that will add in a sequencer track for you with the lifetime of the particle, and you can actually click cache and it will cache those as well. So it's better for deterministic, like scrubbing, being able to render it out of MRQ and MRG. And then a couple other things, I just put them on the slide, but so we are pushing toward being able to use our end display technology with the motion design tool set. So with this release, we have an integration with end display where you can put it into a clustered form. And so if you need a big canvas and you need things to be synchronized fully across those canvases, then you can do that. And then we're also adding support for NDI, so be able to do some more of the network protocols that are here today. So yeah, that's kind of it. I ran through it rather quick because obviously the keynote was running long, but it'll give us a little more time for questions, and I'll be around obviously to cover anything that you guys need after this. But if you guys want, I know there's a microphone up here, and just come on up and we'll chat for a few minutes, and I'm going to be around after in case you don't want to ask publicly. But yeah, thanks so much.
Am I on air? On air. Hello, my name is Ryan Maeda. Thank you for coming to this presentation, which is State of the Union Virtual Production. We're going to step through a wide range of features that are, come from the film and TV world, but have, hopefully a wide-ranging impact across all the different things that Unreal Engine is used for. So we'll start with the rendering pipeline. So previously on Movie Render Queue, we've been working on this movie render graph setup, and as part of that, we've gone through the process of decriminalizing compositing and making sure that the engine is able to produce elements that are suitable for post-production. This is one of my favorite presentation graphics I've ever made, so I'm getting one more use out of it since we've now shipped the feature, right? But in the 5.4 release, we moved the kind of stack-based preset system in Movie Render Queue, and we shifted it over to a graph-based paradigm, right? So we kind of flipped the existing settings on their head, keeping a relatively simple base setup, but then we also introduced more sophisticated concepts like collections and modifiers, and these are the things that drive your ability to isolate, just the character or just the background or just certain elements, separate them from the background and produce separate elements that can be composited together in post. And so in 5.4, we shipped this out, right? So hopefully people are starting to get into it. It's a feature set that we worked really hard on and we're really excited about. And there's a big range of new stuff coming, stemming from the initial release, with the focus areas, there are kind of three main things. There's first, just continuing to advance the rendering features. There were certain things that didn't quite work the way you would expect, and we're just kind of iterating through all of the different things that the engine can render, making sure those things work and are friendly with render layers. We also got a ton of feedback just from artists and trying to make a really artist-friendly tool to set up these a range of simple, sophisticated scenes. And then kind of last but not least, we've been looking at a lot of the parity aspects as well. So making sure that everything that the previous Movie Render Queue can be accomplished in the graph as well, right? So stepping through this, first thing to note are heterogeneous volumes. So this is an example of a type of asset that would be really great to render in separate layers for post purposes. You can take a big shot like this that I re-rendered from Fortnite that has this awesome VDB-based sim, and now you're able to hold out the sim, send it just the background over to the compositor, and then also isolate just the dust cloud itself. This was something that wasn't quite working in the previous release, and it's an example of something that we've been able to improve in this release to support all asset types. Another example of something that was really a common hurdle in the previous release was translucent objects. So we had limited support for translucent things. If you look in anybody's scene, you're likely to find a lot of translucent stuff. And so in the previous release, we had issues like this, right? So in this shot from the Meerkat, if you held out, the Meerkat, the alpha would have the eyes in it because they were translucent. And obviously, this is not something that your compositor would be happy with. And in 5.5, this is something that's been addressed, right? So an example of this would be a car shot, like this was shown in the keynote. But if you're looking at this, the new support will allow you to make a mask easily for just the windshield in this simple example, right? And then you'd also be able to isolate the glass really easily if you're going to further adjust that in post. So this is a long way of saying we've made a real emphasis, and we're proud to say that essentially all asset types are supported for render layers, right? So this also includes Niagara, which was reliant on some of these issues being solved with translucent objects. We also support landscape and sky atmosphere without a sky sphere. So there's different ways that the sky atmosphere can be set up, and now we support both ways. On the settings side, another thing that was a common pain point with the initial rollout of render layers was spawnables. So if you look at any cinematic or anything with shots in it, you're going to find a lot of spawnables. And so this was a problem for isolating them because they're transient and the system was not able to grab on to something that was spawned. And so in this release, you're able to reference transient actors by name. So instead of having to go through and put tags or come up with some convoluted system for finding all the spawnables that you want to isolate in a render layer, you're just able to use their name. So you don't need to use these kind of tag workarounds. It's that were cumbersome to set up. And we aim to support explicit actor references in a future release. We're working with the sequencer team on being able to pick a specific spawnable as well as just reference them by name. But we thought it was important to do the name thing just so that you don't have to do any additional setup within your actual within the level itself to use them in layers. On the media output side, we've moved over the ProRes and Avid DNxHR options to the graph. And as part of this, we've also improved the output quality and options for these. So we moved these over, but with a lot of the stuff that we're trying to to transition from the preset system to the graph, we're also like seeking out these opportunities to make each one of these little component features better. So for Apple ProRes and ZNXHR, we offer like all of the standard quality options. So if you've ever used these outputs before, they were previously hard-coded to just one option. Now we support all of the options so that if you're rendering out editorial media from the engine directly, like the flavor of choice for your editor is available. And then also on the editorial side, we've ensured that timecode support is proper for these outputs, right? So if you have timecode and sequencer, the editorial media that's ProRes or Avid DNX will have the timecode embedded in it to match whatever you have in sequencer. Metadata is another important part of a rendering pipeline, and this is something that's been added for EXR. So there's a node that you can just drop in and set like key value pairs for your metadata. This is a good way to configure custom attributes, and those will just automatically get written into the EXR when you output it. It also simplifies the way you might do this in a pipeline. So instead of having to write some Python that like waits for the render to finish and then sticks the metadata in, like your Python script can just add a node and put it all in there, and we take care of all of the heavy lifting. Just wanted to give a shout out to Weta. I don't know if anybody from Weta is here, or maybe they'll be watching, but this is something that Weta worked on. They contributed back to the engine, and it was just a nice feature add that they helped us out with, so I wanted to give them a shout out. Console variables is another thing we focused on, right? So render settings are very commonly console variables, and dialing these things in correctly is an important part of getting good output from Movie Render Queue. So to that end, we've made some adjustments. So if you're using a console variable preset, we now list out all of the console variables that are in it and their values, just to give you a little bit more transparency over what's being set. We've also made some small adjustments that kind of go a long way towards reducing clicks and simplifying things. So if you want to expose a console variable as a movie render graph variable that the artist can change at submission time, we automatically name it, we automatically set the default value. So then it'll show up here on the graph, right? So if you set the graph up, maybe you want to have this laid out in a way where the artist doesn't have to open it up, but they have common settings that they may want to adjust. This gives you a way to kind of surface that up, give it the right name, give it the right default value without any mistakes. And then another thing that we've added to the queue window is the ability to just set a console variable as an override. So this is really handy for quick testing, right? So you don't have to open the graph to test the new CVAR that may or may not fix your render. So it's kind of a small thing. I feel like console variables have become a little bit of a pet project of mine. And I think in all cards on the table, it can be hard to find what the right console variable is. And I think from a tools development standpoint, something that I've really prioritized with our team is just making it easier to manage them. These CVARs go a long way, and anything we can do to make them easier to set, easier to find, helps people get good output. This was mentioned in the keynote, but I just wanted to call it out. There's some updates to the path tracer temporal denoiser, right? So this is kind of an extreme example going from bottom to top of no denoising. And then now we have this new temporal denoiser, which is built into Movie Render Graph. And so if you are using the path tracer, we encourage you to try it out. We think that you're going to get a lot better results. Object IDs is an example of another thing we moved over. So the previous ability to export object IDs as part of your render is now available in the graph as well. And then we also added support for rendering all cameras in the graph. So this is a multi-camera setup, common in an automotive type of thing where you set up all these cameras in the scene, you want to render them all at the same time. This wasn't supported in the graph in the last round, but we've moved it over. Other small but mighty things, so this is something that we spent a lot of time on, a lot of little things getting added up here, but start-end console commands are now available as a graph node. A lot of people drive logic via Blueprint as part of their scene setup, so these are available in the graph. Script tags is a pipeline-centric feature that that makes it easier for a script to find the right node if it needs to adjust it, hopefully making it easier for TDs to build things out in their pipeline. And reference motion blur is also available for the path tracer now. Looking ahead to the next release, we kind of envisioned this feature as a 3-release cycle of 5.4, 5.5, and 5.6. So what we're aiming to do in the next release is hit full parity with the legacy preset system and call Movie Render Graph production ready. One of the big missing features that we haven't moved over yet is the high-res and panoramic options. These are things that we want to spend a lot of time on and improve, specifically improve from where they are now. If you've tried these out, you probably have run into things like memory issues and just it's it's not a stable system, or to the level that we would hope. And so this is going to get a lot of emphasis in the next round to make sure that when we move it to the graph, the high-res and panoramic options work a lot better. And then kind of last but not least, introducing some quick render concept. I don't know if that's what we're going to actually call it, but thinking about like how many clicks it takes to go from like I'm in sequencer to I want to render, hopefully getting to a place where there's like a one-click option that just renders immediately. That's from a UX standpoint. We've invested really heavily in being able to do these fancy graphs that are really sophisticated. So we want to kind of balance things out in the opposite direction to make things faster, easier, and just like a smoother user experience for rendering in the engine. On the Linux side, for anyone using Linux, there's some housekeeping here, which is that we've moved away from supporting CentOS. If you're a Linux-centric studio, you're probably aware of what's going on with CentOS in general. The industry has, for film at least, has moved towards like this, established some guidelines, some recommendations, specifically that people move towards Rocky 9. And so that's something that we've adopted as well. A lot of times when people ask us, how we can make Unreal on Linux better, like using newer Linux actually helps us a lot. Like as a real-time system, staying on these older components can really slow things down, and the newer components will oftentimes run faster. So it's just something to be aware of. And then as of this release, we're kind of making an official move away from CentOS entirely. Also on the Linux side, they kind of, I think they touched on this in the keynote, but Vulkan ray tracing is now enabled by default. It's essentially reached full parity as a starting point. So like we're really interested and eager to have some production start to try to use it, start to like make it even more refined and robust going forward. Switching over to ICVFX, quick recap of a couple features that we had in the last release that we're really proud of. The first one is depth of field compensation. So this is a really cool feature, one of my faves, I would say, by far. Like thinking back to when we worked on first season of Mandalorian, there was this moment where Greg Fraser he came over to us and he was like, hey, so when the movie camera films the wall, like everything is the same level of defocus, right? Even if it's in the render and it's going behind, because the real camera is just seeing everything on the wall the same. And it was something that always stuck with us. Obviously, we weren't able to do it at the time. But in 5.4, we introduced some new features to the render that allow it to compensate, because we know where the camera is, we know everything about the lens and all of its characteristics. And then we also know where the wall is. So we're able to make these adjustments. And the result is a much more realistic depth of field that allows people to just, ideally, people are just running with it all the time. But in the past, you were either turning it off entirely or getting a double blur, and this is something that we've addressed with this compensation feature. On the 2110 side, we also introduced this inner frustum split feature, right? So using 2110 to slice and dice the renders up a little bit more, it allows for additional resources to be thrown at the in-camera pixels in the inner frustum. So instead of having to render this with one machine, you're able to like split it up, potentially throw multiple resources at it. Like a simple example would be just dividing it into two. But we've seen some other people try to go even higher res and push more hardware towards the inner frustum. And so with 2110, you're able to split this up even more. For really, really large volumes, doing really, really wide shots, like that resolution can potentially make a difference. And so it's cool that we're able to give people more flexibility to throw more GPUs at it if they really want. Looking ahead here for 5.5, like the main emphasis has been on continuing to get 2110 solid. So in this release, we're feeling really confident about the NVIDIA RiverMax setup. We're calling it production ready. We're starting to see studios begin to adopt it. A lot of, I wasn't sure what to put here visually, right? Because a lot of it is just like making sure it's in sync and all of these like lower level technical features that, the end result is that the wall looks the same. But you're able to do that more efficiently. You're maybe able to have a more sophisticated scene. Like there's a lot of efficiencies that 2110 brings. And so we're happy to say that we think it's ready to go. Also on the 2110 side, we're beginning to work with other hardware partners. So one of them is Matrox. Matrox makes a ton of gear that people already have, especially in the broadcast world. And so we're kind of starting, now that we feel really solid about the RiverMax setup, we're going to start iterating through these other 2110 cards to make sure that they have support as well. So Matrox is the next one up. There's also going to be a panel that I'll plug here, but if you're interested in it, they're going to be talking about the AMD and Matrox-based 2110 setup for in-camera VFX. There's also a booth in the near the Dev Hub downstairs that you can check out as well. But the team from AMD and Megapixel and Matrox are going to be talking about this with me tomorrow. On the usage side, a lot of a lot of what we've done for in-camera VFX to date has been on like refining the core components. And one of the cool things that we've been able to do now that things are more solid is that we're able to focus on making things nice. So this is an example of something that every time I go watch operators, it's tripped them up, right? So being able to manage level visibility. So operators will like have stuff in sublevels, they'll hide and unhide them, and they weren't able to do that in end-display. It was just really hard. We had these CVARs to like try to sync it. It was a really, really common pain point. And so we worked with the editor team. We finally got this like simple column that I think will go a really long way for operator happiness, right? So in the levels panel, you can now expose a game visibility column. And so this will show you the state of it, right? So you'll be able to toggle these things live as long as they're loaded, right? And then there's just a little basic eyeball, and this will let operators toggle the visibility live in end display. I hope that and on a personal level, I look forward to not having to answer another support ticket related to the level visibility not working. And so, this is it's one of those things that I've just always wanted to do. It's just so we're in there. And here's another example of a refinement. Like when people start to really massage the light cards and work with their DPs on it. We have this ability to have the light cards either over or under the inner frustum. Right, so this is an example where you could set the default to be under the inner frustum, which is generally the common case, but every once in a while you may need to put one over in a corner. And so now you have the ability to like opt out. So on a per light card basis, you can go over or under. Another thing to talk about is content plugins. So we'll see how this fares. But like with any of the stages that you'll see, like projects come and go, right? So one day maybe you're filming a camping scene, right? Another day, like you might be filming a Western. On a third day, you'll be in the city, you'll be in an underpass, and maybe on another shoot day, you'll be playing chess. Right, and so like what you end up having to do for a stage is like you're getting all these projects. They're probably coming from different partners or different productions that are just sending you these projects, right? So what you end up having to do is you have to recreate all of your content in like over and over, right? So you have an end display, you have a stage level, you have your camera track, and you have a whole bunch of stuff that's like always used on every project, right? So then you got to copy it over here. Maybe you make a change and then you copy it again. Like these things get out of sync. And the idea here would be that you can wrap them up into a plugin, right? So we use this internally. We have a plugin that we put all of our stuff in. It's called Stage Essentials. You can call it whatever you want. This is just an example based on our own life. But what we have now is this ability to have additional plugin directories, right? And so like this feature existed before, but we've made a small change that makes it more accessible. So in any project, you can just open this up in the plugins folder, and now there's this place to define an additional place to look for plugins that travels around with your project, right? You don't have to set an environment variable. You don't have to remember a command line argument. You can still do that if you want to, but this just puts it into the U project. It's always going to be there. So wherever you move the U project to, it's going to find it. And so like we encourage stages to check this out. This stuff kind of drives me crazy as well. Like we have different projects. Sometimes we change the end display in one, and then that change is not in the other one, and we get really confused, and we waste a lot of time doing that. So this is an example of a feature that we prioritize because we believe this is going to make stages run more efficiently. It's also applicable to VCam stages, performance capture stages, really anything, right? So anything that you have reusable, even if you don't do any of this virtual production stuff, like you may just have stuff blueprints that you use across all the different projects. All these things that are reusable, I encourage you to check out this content plugin idea and start to manage those so that you don't have to copy stuff over from project to project over and over again. On the iOS side for Unreal Stage, a couple minor things, like if in a project where you have a lot of light cards, you may notice that it gets cluttered with a lot of pins. It becomes really hard to pick the pin that you want. So we have a show only selected option. This kind of drills it down, makes it easier to select the light card that you want to move. We've also added some additional support for color correction regions in the app. So now we have transform controls. You can add CCRs instead of CCWs, or in addition, I should say. And you can move those around with the XYZ transform sliders. On the plate playback side, we have a new feature called Holdout Composite. And the idea behind this feature is that this uses the holdout setup that we developed for Movie Render Queue, and essentially like punches a hole through the scene when you play a plate and just puts the plate back on. So a lot of times you may have to run, you may have these artifacts, related to things like TSR or some of the other engine features that affect the plates. And so if you use the Holdout Composite, this just plays the plate as is. It's potentially a good option if you're using Unreal for plate playback. Looking ahead, we're kind of starting to shift gears and start looking to some new workflows beyond just the LED wall. And so in 5.6, we're hoping to make some improvements on the live compositing side, specifically some simulcam tools, kind of refreshing some of the older feature sets like Composure, figuring out how we're going to do a good, a modern implementation of that. So targeting relatively basic setups like ARB comps or potentially these kind of AR style graphics. It's something that we're starting to research. Our rendering team has been working really hard to help us out. And then a lot of the work that we've done for post-compositing is going to be applicable. So some of the rendering updates we've made, we believe that we're in a better position to tackle live compositing, and so that's going to become a priority in future releases. Another thing to mention on the artist side is the color grading panel. So if you've used the in-camera VFX editor, you might have noticed that we've introduced these kind of grading tools. And in the 5.5 release, we've promoted those up. So this is now available across the engine. You can always open this color grading panel. This is one of my favorite features as well. I'm really happy that we're able to make these features that are really nice for artists. So it's something that always bothered me when you're grading, which everybody does in every scene. You've got to go into the details panel and you've got to scroll it down, and you can never tell if you're on global or shadows. So this is a much more intuitive. This is what I just feel like this is what color grading UIs are supposed to look like. You can see them all at the same time. You can grade your post-process volume or your cine camera or anything that can be color graded, right? And also lets you manage the CCRs. If you poke at any scene that uses color correction regions, you're probably going to find a lot. Oftentimes there's tens, maybe even hundreds in there. So managing those, syncing the selection with the outliner to move them. This is a dedicated tool for color grading. On the XR side, right? So we're continuing to advance our virtual scouting tools. The XR Creative Framework that was introduced a couple releases ago has gone to production ready. I think the main improvement here is the gizmo system. The editor team has made some improvements to gizmos that we were able to leverage in VR. So these are much more comfortable ways of moving things. I feel like whenever I was VR scouting, I tried to move something, I would never be able to move it the right way, right? So this, as you can see in this video, it's an example of how you get this nicer, fine-grained movement. Also on the kind of AR XR side, I wasn't quite sure how to categorize this, but there's a new plugin called LiveLink OpenVR. So it's a little bit confusing. I'll try to explain it, but it's targeted at the puck, right? So everybody's seen these pucks. They're oftentimes the way people learn camera tracking for the first time. And with the transition to OpenXR, there were a bunch of problems with the prior LiveLink XR plugin. And so it turns out that there's this other framework that you can use called OpenVR, this allows this has better support for the pucks basically, and you can run it headless. It's not as cumbersome to set up. So if you are a production that uses these pucks, the OpenVR plugin will work a lot better. It kind of brings it back to this classic, the classic standards comic where the devs had to explain to me what the difference between OpenVR and OpenXR is. And this is totally one of these things, right? I thought we were supposed to be using OpenXR, and then it turns out there's an OpenVR. But the reality is that the pucks are going to work better with OpenVR, and so that's why we support it. On LiveLink Hub, we have third-party plugin support, right? So LiveLink Hub now allows for the third-party plugins to be external, right? So all of the different performance capture plugins like Motive, Shogun, Makopi, et cetera, those can all be externalized. So if you're doing performance capture in UEFN, you're able to plug and play these things much easier. And then this is kind of starting to give rise. LiveLink Hub is a really foundational piece for what's coming next. For some of the performance capture stuff. Timecode was also an emphasis on the performance capture side. Like in this release, you're able to see sequencers timecode in the viewport. The animation asset editor now displays timecode, which I didn't realize it didn't do before. Live link subject take recordings now receive timecode tracks. And we have media timecode support in sequencer, right? So a lot of this kind of groundwork stuff is like, for people that know timecode, you're probably looking at this and you're like, yeah, it's supposed to do that. And that's true, but the reality is that it didn't do it yet, and we needed to address it. I forgot the subframe thing, but we also support subframes in Take Recorder now. This is kind of like building towards what will become a real point of emphasis, like going forward, right? So we've spent a lot of time with like the groundwork, with LiveLink Hub, these kind of timecode examples. And performance capture is going to become a feature set that we want to elevate to the kind of in-camera VFX toolset level within the engine. We think that performance capture is a critical part for real-time animation, right? So the ability to use the real-time nature of Unreal, capture something live in the moment with real people. And it's also equivalently important for us to make sure that the performance capture the performance capture that's recorded feeds into the in-engine animation tools as much as possible. So this is being led by Richard Graham. He's not at Unreal Fest. But I think next year he will probably be standing where I am, because our feature set's going to be very performance capture centric. Looking ahead, like the key areas of development are the introduction of a mocap manager. Like this will be a dedicated UX for performance capture operators. Kind of thinking like how we did for in-camera VFX. There's a dedicated experience for the stage operator. It's going to be a similar idea, but for performance capture. The connection animation is going to be critical, right? We want you to be able to start with performance capture and seamlessly continue with in-engine animation. And then last but not least is Take Recorder, right? So Take Recorder is something that we've always wanted to revisit. And it's something that we'll be spending a lot of time on to make sure that Take Recorder is robust, reliable, both for performance capture and everything else. So that's kind of a big job. This is going to be handled by Thomas Kilkenny, right? So Thomas and Rich are going to be working together to deliver this awesome performance capture feature set. On the VCAM side, a few things to mention as well, right? So actor replication is something that's been refined, and it's a way for, like, I think a good example of this is with VCAMs and/or like controller input, right? So if you're in a collaborative session, like a lot of VCAM sessions will make use of both of these things, and it was just hard to. We found that it was very hard to share that across the multi-user session. Right, because it's one actor, like maybe multiple people are touching it, and it would be cumbersome to edit them at the same time. So with multi-user application, you can replicate actors in real time. You can just pick an actor, pick some properties, and it's going to be replicated live. It's not based on the transaction system, which you can still use for regular changes that you don't need to be immediate. And it's useful for things like virtual camera and controller input. So like for a controller, for example, you can set up the controller. It typically goes to one of the computers that are in the session. And now instead of having to figure out a way to like duplicate the actual input, you can just duplicate the actor that it's applying to, and that's going to go out to all of the rest of the clients in the multi-user session. Also, if you're making blueprint tools, you no longer need to wrap changes into a transaction. So this should hopefully lighten the load for something that you are building into a blueprint that you want to happen live during whatever it is that you're doing in multi-user. Another thing we've added on the camera side is overscan officially. So all camera actors have overscan. This is built in, and we have optional resolution scaling and crop. This value gets passed over to Movie Render Queue. If you set it on the camera, you can also set it directly in Movie Render Queue. And the example of this would be like you're using overscan. Maybe you're going to be able to improve the screen space post-processing accuracy. Maybe you're going to add camera shake in post, right? So this is a common camera attribute that just was missing, and now it's in there. And then kind of last but not least, you can distort the image with a lens file, including overscan. On the lens calibration side, we've moved the solver over to like production ready. A lot of work has gone into improving the accuracy of the camera solver. We're able to leverage a little bit more of the tracking information to make it so that you don't have to precisely mount the tracking devices to the same degree. There's also some rendering improvements where the lens distortion is applied as part of TSR. So you should get better visual results. And then on the workflow side, you're able to run the lens calibration and the nodal offset at the same time instead of as separate steps. For VCam, there are some features that are oriented around like being able to visualize the stuff that you've already recorded a little bit easier. So there's a bookmarks browser with thumbnails, right? So when you make bookmarks, you'll be able to find them much easier thanks to these thumbnails. And then likewise, there's a take carousel, right? So any of your recorded takes will now automatically have thumbnails. And so when you're browsing for prior takes to pull them up, you'll be able to see them. We'll kind of close out with another new initiative that we're looking into for the engine, which has to do with shots, right? So I use the Meerkat a lot for all of my own testing. I'm sure a lot of people in the room, it's oftentimes their first project, right? It's a really great project to learn, but ultimately it's a small project. I think it's like 20 shots, right? So if you think about using Unreal and scaling out that usage, you're gonna be like expanding out to like potentially hundreds or thousands of shots. And this is hard to do in Unreal, right? So this is kind of leading us to this question, right? What is a shot in Unreal Engine? It could be a great number of things, right? It's a level sequence, it could be the animation, maybe what about your lighting? Where do all these assets live in the content browser? So to that end is a little bit of like an existential question to some degree. So that's why we have somebody who majored in philosophy assigned to this feature. It's Thomas Kilkenny. And so Tom is going to be leading the charge on this shot setup, and it's kind of a sprawling project, and there's a lot to figure out. We see a lot of people build systems that are just like creating a shot. Like we want the shot to be a certain name. We want to put the shot in the correct folder. That's all kind of part of it. And then on the sequencer side, what is the shot can be many things with all the subscenes. Like how do we organize that? We talk a lot about, or we think a lot about editorial integration for sequencer, and you think, oh, it should be really easy, right? Like, they're both timelines. Why can't we just move them back and forth? Like, I've always been of the belief that, we need to know knowing what the shot is like the key to figuring that out, right? That's what gives us a reliable mapping that we can go back and forth between other editing systems. And so there's a lot to figure out here. I think that we'd love to talk to anybody that's kind of, especially people who have built shot systems or people who have thoughts on how they organize shots, how they think about shots within the engine. It's a big project. I would love to talk to you about this afterwards, and we'll connect you up to Thomas for some follow-ups. But it's kind of a little bit of a research project, but we're still trying to identify work that we can do starting in 5.6. It's going to take several releases for us to get there, but we believe it's like a really important foundational piece for us in terms of moving things forward for all types of film and TV projects. That's it for me. Hopefully we have some time for questions. How did I do? Yeah. Okay, so we've got like 10 minutes of questions. You can yell them out or come to the mic. I will do my best to answer.
Thank you so much.
shit, it's 2 people I know. Hey,
So this is going to come from the machine. It's going to be full volume, yeah?
Yep.
Okay. Hold on.
Hello, everyone, and welcome to Riot's multi-game Unreal-based development ecosystem. Also, thanks for taking the long trek to room 421 right after lunch. That was difficult, at least for me. A couple things about me before we start. My name is Daniele. I started my journey in the game industry in 2011 with Havoc, where I was working on middleware for multiple AAA games, a lot of AAA games. I saw a lot of bespoke game engines at that time. In 2016, I joined 343 Industries and Microsoft, where I was working as an architect on Halo Infinite that eventually launched in 2021. And on 2022, I did the jump to Riot. I'm currently an engineer in the Unreal ecosystem team at Riot, which is the team responsible for the shared game development ecosystem that we're going to be covering in this presentation. So the agenda is pretty packed today, so I'm going to be moving a little fast. I'm going to start with an introduction, discussing the problem that we're trying to solve and what it means to attack it with a shared ecosystem solution. We're then going to do a deep dive in the architecture and structure and functionality of the Unreal ecosystem, the Riot Unreal ecosystem. We're going to talk about engine modifications that we ship as part of the ecosystem, examples of shared plugins, and examples of shared infrastructure and tooling that make the ecosystem functional for our developers. I'm going to then take a kind of like a sidewalk into our development philosophy and what it means to live into a collaborative ecosystem development environment. And then we're going to do some conclusion. Hopefully, we're going to have some time at the end for Q&A. All right, let's get started. Introduction. So the problem that we're facing at Riot is we have a number of game teams. Some are for existing games, some are for new games, and some are just R&D teams that are doing R&D efforts trying to find new fun for our players. So what we found is that, especially for these early prototype R&D efforts, there is always a significant amount of work, technical work, that is required to stand up any kind of multiplayer Riot game experience. This is effectively overhead work because it's distracting from the game teams or the R&D team's real job, which is making a fun and great game for our players. Not only this is like effectively overhead, it's also duplicated across all our teams, whether they're new or old. And so in general, it's very wasteful. On top of that, making AAA games is difficult, as all of you know, and making AAA live games is especially difficult and expensive. And this is basically all that Riot does. And operating them is also expensive. So at Riot, we're always looking for ways to minimize our technological complexity so that we can make sure that our game team's time is going as much as possible into player hands as player value. And also so that we can be very flexible and agile in this rapidly evolving market, which is the game industry. So to attack at least a portion of all these problems, what we propose is a Riot-wide shared game development ecosystem where game-agnostic tech challenges have an out-of-the-box solution. The high-level goals that we set ourselves for the ecosystem are kind of the four in the slides. First and foremost, we want to allow all of our game developers at Riot to focus on making great games, offering turnkey solutions to all game-agnostic problems. This effectively means kind of bridging the gap between what Unreal provides out of the box and what it means to ship a AAA game at Riot. We want the ecosystem to be open so that we can accept contributions and solutions from all of our game teams and all of our developers across the organization. We have a lot of talent at Riot, and we don't want to shut them off from contributing great solutions to the ecosystem. We want to establish a set of shared best practices and standards to facilitate tech sharing and talent migration across games. And last but not least, we want to have a central team at Riot that is responsible for directing, supporting, and evolving the ecosystem. And this is mainly about establishing a single point of accountability. So this kind of high-level thinking led eventually at Riot to the formation of a central tech team that is called the Unreal Ecosystem Team, or UNICO for short, which kind of sounds like unicorn. So we had this really cool, kick-ass unicorn logo made for us. And the construction of the shared game development ecosystem that we named Core SDK. If now you're wondering how we came up with such a cool and creative name for our ecosystem, well, I am 2 years in, and I'm still wondering that myself. Before we get into the meat of the talk, one thing that I wanted to mention is that the first game that Riot will launch that was built on top of this ecosystem is 2XKO, formerly known as Project L. And so we're very excited to get this in the hands of the players and get all this technology in the hands of our players. So I couldn't help myself but put a video of the game in the presentation. So please enjoy.
Don't look away. Are we hurting each other for sports?
Face the wind. Stand with me. We call the weak. Starting now.
What? Replay! Time to throw down. About time.
Cool. Thank you. All right, with that out of the way, let's get going into the Riot Unreal ecosystem. So this is a high-level diagram of the entire ecosystem, and I know it's completely illegible, but don't worry, I'm gonna be zooming into pieces of this diagram as we move along. For now, just focus on the two bigger boxes. The black box on the outside is the entirety of the ecosystem, the CoreSDK ecosystem, and the white box underneath it is what we call the CoreSDK engine, which is effectively a package that we centrally ship, similarly to how Epic ships Unreal Engine versions to our internal game developers. At the heart of the ecosystem, there is the Unreal Engine, of course. This is an Unreal Engine-based ecosystem. One thing to note is that we have a number of changes to the Unreal Engine that we ship with this CoreSDK engine package, and we're going to be discussing a couple of them later in the talk. Central to the functionality of the ecosystem, there is a layer of shared plugins, which we call CoreSDK plugins, that implement a variety of functionality on top of what Unreal Engine ships out of the box. There is roughly 100 or a bit more than 100 plugins at the time of this talk. And in this slide, I've just organized them roughly by area. Some of these are not individual plugins, but families of plugins. But overall, all of our plugins kind of fall in two big categories. We're either trying to bridge the gap between what Unreal Engine has and some other kind of Riot technology that we had and that all of our game teams are meant to utilize. Or we're introducing new opinionated, improved workflows for our own developers on top of Unreal Engine. We're going to cover a couple of examples of these plugins in the talk. With CoreSDK engine packages, we also ship a set of shared build jobs that all of our developers are meant to use to perform common automation operations, like building the editor, building the game, and cooking the game, test automation, et cetera, et cetera. I'm going to be covering a little bit more on details this later in the talk. Outside of CoreSDK engine releases, there is a number of infrastructure deployments that support the functionality of the ecosystem for all of our developers. And there's some probably names that you recognize here on the slide. And I'm going to be covering a couple of examples later in the talk as well. Of note, this actually ships outside of the CoreSDK engine package releases. So it's something that Unico either deploys or operates for all of our developers. One interesting keystone of our shared game development ecosystem is our standardized directory structure for all of our games and even the Unico team itself. If you focus on the diagram on the left for a second, our workspace structure kind of shows the engine folder, which is probably you're familiar with if you're an engine developer. But on top of that, what we have is we have a CoreSDK folder that includes the vast majority of all the shared technology that we ship as part of CoreSDK engine releases. For instance, in the plugins folder there, we have all of our plugins. All of our game teams are also using a standardized structure for where to put their actual Unreal projects that are inside that project folder with individual Unreal project subfolders. And then we even have a team folder at the bottom, which helps game teams configure CoreSDK in a team-wide manner, overriding its default behavior. So in general, the standard directory structure is foundational for our shared ecosystem because it enables simpler integrations between Unico and game teams back and forth, and between game teams as well. Also, because we have established this CoreSDK folder completely separate from the Unreal Engine folder, this structure clearly separates what is Riot ecosystem technology from Epic technology, which allows us to create different levels of controls. We support, as I mentioned, overrides to CoreSDK default behavior, either project-specific or game team-wide, and it's kind of mainly implemented within the config and build subfolders in there. This standard directory structure is talent moving across teams, game teams or otherwise, because as soon as they move, they find themselves in a familiar environment, at least for anything that is shared technology that ships with CoreSDK. Another interesting backbone of our game development ecosystem is our approach to version control. We use perforce, like Epic does internally. And I'm going to be walking through this diagram from left to right. But one thing that is important to note is we have one single massive perfor deployments at Riot for both the Unico team, CoreSDK development itself, and all of our game team, all of our Unreal-based game teams. So we start from the left here. The Epic upkeeps this licensees, what they call the licensees per4 server, which is a per4 server that Epic operates. It has all the releases of Unreal Engine. It has the mainline. And what we do is we mirror this, or at least some streams inside this depot, internally into our per4 server deployment on a depot that we call the Epic licensees P4 mirror. These kind of blue cylinders are P4 depots in our P4 server deployment. The Unico team kind of upkeeps this core SDK depot. And one key thing here is that the Unico team is the one team at Riot that is responsible for intaking UE version upgrades into core SDK and upgrading all of our central technology, including all of our shared plugins, all of our shared engine modifications. And those are upgraded once for all of our game teams. Each game team has its own depot in our per4 deployment. And I'm showing two examples game teams here, like game 1 and game 2. Wasn't allowed to put names in there. And the key thing here is they have different depots so that our per4 managers can clearly control the lifetime and access for different game teams. But when game teams update their engine versions, what they take is they take a core SDK release. They do a core SDK, what we call a core SDK engine upgrade, which are those arrows there. Each game team is kind of owner of their own depot, so they can decide however they want to work in terms of like what streams to create, where to put the various efforts. But one thing that we have standardized on is the chain of streams that we use for intaking and integrating core SDK engine releases into any given game. I don't know why the arrow at the bottom is not showing. But in practice, the way this looks is the game teams work in, their mainline is called the dev main branch in basically every depot. And the structure of the other streams that we use for engine upgrades is kind of the standardized structure that Epic also recommends. Effectively, a game team will take a core SDK engine release, and they would copy that into their X core SDK stream. They would then integrate that with their game in the ITG core SDK stream, do all their testing and validation, and then eventually do a merge down copy up to their mainline. Each of these streams also respects the standardized directory structure that I mentioned before. So this is where it's coming into play. These arrows are kind of interesting. So these dotted arrows represent not full integrations, but kind of cherry pick integrations. So the ones on the left here say upstream contributions. And these are effectively backwards flowing changes that go from the game teams into the core SDK ecosystem. And I'm going to be talking about that. They're part of our open development philosophy. And the cherry picks arrow here, it just represents the fact that game teams are, because of the standardized directory structure, because we all live in the same per4 server, they are able to directly integrate from one to another if they're trying to share some technology with high bandwidth. The fact that we live in this one per4 server deployment is very interesting for us because the funnel of intake of UE versions is unique, and because eventually all game teams integrate the same core SDK releases, these kind of cherry-picking integrations are never performed as baseless merges. So the merges are simpler than would they otherwise be if they were just baseless. OK, let's switch gears a little bit and talk about engine modifications. So in general, we try to avoid modifying the Unreal Engine. As you all know, it makes it simpler to intake UE version upgrades if you don't modify the engine. However, one thing that we've found is that some features simply cannot be implemented as plugins or existing extension points in the engine. For instance, we have a number of UBT behavior modifications. Some plugin features that we want to implement because they're kind of key to some of the workflows that we like to provide our developers are also very difficult to implement without altering the behavior of the engine in some way or introducing new engine hooks. This is especially true on the rendering front, we've found. Also, the fact that we are able to distribute one centralized modified version of Unreal helps us share with all of our developers important engine fixes that they would probably need. Or also, it allows us to deploy cross-team configurations modifying the base INI files. So these are some of the examples of why we sometimes modify the engine. In practice, though, we have some very strict guidelines that we try to put in place. In general, we try to, in order to avoid engine modifications, as much as possible, we try to override default engine classes. We try to use horizontal injection using subsystems and actor components. And when we're modifying the engine behavior, we try to modify the default engine behavior if the corresponding core SDK feature is not enabled by the game team. We also always use object-level serialization instead of global versioning, like the object licensee's UE version number, which can be extremely dangerous in a multi-game ecosystem. We tag all of our changes so that we're able to use this tagging and markup for subsequent integrations. And we have an explicit sign-off process for engine modifications going into Core SDK. So an example of such engine modification is our approach to build acceleration. So at Riot, all of our games, even the non-UE games, use FastBuild for build acceleration. There's a lot of in-house expertise. This is an open source build acceleration framework. And one interesting thing about FastBuild is that it shares object files directly with the developers that have been built by CI, or even by other developers. This means that because the build output can be directly shared, most builds are very fast, even on slow machines for us, which is kind of interesting. Here on the screenshot on the right here shows some of this at work. Cache hit means that the FastBuild cache was hit, therefore we download an object file instead of building it. There's a FastBuild integration that ships out of the box with Unreal Engine, but it's very bare bones. So what we've done is we've extended it in a number of ways. First of all, we leverage Riot's CDN and the patcher, the same patcher that our players use to update their games, to distribute these object file caches. We also added FastBuild support for a number of missing target platforms that we want to target, like Android, iOS, Linux, PS5, and Xbox. And we have modified UBT so that we can use a uniform compilation static route so that the caching in FastBuild will work regardless of the build path on the local machine for the developer. Another example of engine modifications that we distribute as part of Core SDK releases is related to profiling. So in Core SDK, we standardized around using Unreal Insight and Trace for performance analysis, at least for the first line of defense, performance analysis across platforms. And we standardized around using the test UE build configuration for profiling, because it's close enough performance to shipping, and because it avoids the overhead of some of the other configurations like the stat system. However, one thing that we found is that the vanilla UE test config trace instrumentation, at the moment at least, is very lackluster. So we have added in our centralized distribution of Unreal Engine a number of trace instrumentations so that we can immediately tell what's happening in any of our Core SDK games by just capturing a trace in any test configuration builds. We also have new workflows that we added here around trivially capturing trace snapshots, which is basically a recording of the last X seconds, including downloading this trace snapshot directly from the server so that on the client you can immediately profile what's happening on the server if you think you hit a server hitch or something like that. And also, speaking of hitches, we have integrated our trace additional workflows with the built-in hitch detection for Unreal Engine so that we can upload our trace captures when a hitch happens and potentially debug it. Let's talk about shared plugins for a second. So in this completely illegible diagram, we have kind of a mind map of all the shared Riot online services that we have built for all of our games. These predate the entire ecosystem, and it's what we call the player platform. It comes with a lot of capabilities, and overall, it implements the end-to-end player experience from downloading the game to matchmaking, social experiences, and whatnot. So one obvious area of investment for a shared game development ecosystem is to offer an out-of-the-box integration with all of these technologies that are needed by every Riot game that we ship. So in terms of plugins that I'm going to be showing, man, this is bright. I'm going to be talking about a couple of examples. I'm going to talk about authentication and login, social experiences, and provisioning a game server through Core SDK plugins. So in terms of login, one thing that we've done is we standardized around what is the first run and login experience for all of our games. This is across games and across platforms. This kind of login screen that you can see on the right is kind of what you would expect in every Riot game, and it's customizable per game. There's appropriate hooks that our plugins expose to blueprints so that the game logic can react to certain specific events. And yeah, that's kind of like a uniform login experience that ships through Core SDK plugins to all of our game developers. Another example of shared Core SDK technology that comes in the shape of plugins is related to social features in-game. I'm showing a couple of examples here on the slide. So we have a family of plugins for implementing friends list and chat box. There's a typo on friends, interesting. Yeah, here on the right, there's a screenshot of the friends list plugin, for instance, and here on the bottom, there's a screenshot of a UMG widget from the Chatbox plugin. These are plugins that ship with base classes for UMG widgets that our developers can then use to implement their own kind of look that they want for these kind of social features. But out of the box, we also ship default widgets that they can be somewhat configured by our developers as well. one interesting service that the Riot Online platform offers to all of our developers is what we call the game provisioning platform. This is a service which exposes an HTTP API for effectively allocation of game servers. It standardizes the execution environment and the containers that are used to run our Linux game servers. And the idea here is this service on a live game is actually going to be used by your other backend services, like your matchmaking services and stuff like that. But for early development games that haven't really figured out their matchmaking flow at all, and they're just iterating the gameplay, one thing that we have in Core SDK is a plugin that creates a server browser that our developers can use to just spin up a game server using the game provisioning platform, join your colleagues, and immediately iterate on multiplayer gameplay. And this is also customizable per game team. Another area another example that I want to bring in terms of shared plugins that we ship with Core SDK is related to data, and analytics. At Riot, we love data, and in fact, we have a whole team dedicated to the maintenance and upkeep of what we call the analytics pipeline, which is effectively the funnel for all the data and telemetry that we receive from all of our live games and even our internal playtests. So when it comes to a shared ecosystem like Core SDK, one obvious area of investment is let's standardize how our game developers are meant to utilize all this technology from the Unreal standpoint. So the first layer here is we have an analytics plugin that allows developers to define telemetry events in C++ or Blueprints. There's an example here on the right in C++, inheriting from the RGI analytics event base class. These telemetry events can be sent to the Riot analytics pipeline, and context can be added to the event to tag them so that developers are later able to filter them based on stuff like current level or whatever game-specific context they have. The analytics pipeline and the plugin supports schema and schemaless events. Obviously, all the games we ship are going to use schemad events so that our analytics pipeline is more efficient in ingesting them. And we have a commandlet that ships with the plugin to generate the schemas. This data can be, for our developers, normally is queried and analyzed in Databricks, and reports can be built and shared using Tableau. This is currently best practice at Riot. On top of this basic layer of analytics, though, basic functionality for sending telemetry, we built a number of frameworks. One of these frameworks is called the metrics system. And this framework, basically, the idea is the metrics framework allows developers to collect raw values, whether they're counters or time, during execution, and then aggregate them using various aggregates like average, mean, max, percentiles. And this can be used in a variety of ways, but one of the main ideas is to use this to gather telemetry-worthy performance data and send it to the analytics pipeline through the analytics plugin, but also memory, bandwidth, and whatnot. We have individual plugins that are part of this metrics family of plugins to implement specific facets of telemetry. Like we have a plugin for performance, we have a plugin for memory, we have a plugin for bandwidth. And because this is an extensible framework, our game teams are also able to define their own game-specific metrics that they may want to collect. Like if you're building a jump-heavy game, you may want to collect number of jumps. These metrics are collected locally, and they can be used locally to, for instance, display them in a debug GUI view, like the one on the top right. And, but they can also be sent to the analytics pipeline, of course, through a bridge plugin that we named Metrics Analytics. The metrics framework also supports replicating of this metrics data from the game server to the game client so that locally on the game client, you can tell immediately how the server is doing in some metrics that you're interested in. One other example that I wanted to bring here in terms of shared plugin ecosystems, or shared ecosystem plugins, is actually a third-party plugin. So the fact that we are shipping this shared game development ecosystem with a number of plugins, it allows us to also package third-party plugins with our releases. So in this case, I'm going to be talking about Wise. And at Riot, this is the standard audio middleware for all Riot games. There's a lot of knowledge at Riot around Wise. And what we do is we package the Audiokinetic built Wise plugin with Core SDK releases, but we've also built a number of other plugins and technology on top of it. For instance, we have a first plugin, the RGI Wise plugin, implementing a custom audio actor component that is used to attach audio functionality to actors. We have custom logic to support game feature plugin data organization, which is something that all of our developers are rallying behind. We have a whole audio debug toolkit that is implemented by the audio debug plugin that I was mentioning. And we have additional workflows like a custom VO import tool, especially for localized workflows, and a series of shared build jobs that are related to Wise. This screenshot here is from our audio debug toolkit, which shows a number of in-game debug GUIs that our audio implementers are meant to use to understand what's happening with audio in their games. OK, let's switch gears a little bit and talk about shared infrastructure. So when it comes to shared infrastructure and support of the ecosystem, the biggest and probably most important piece of infrastructure is our build system. So in CuriosityK, we standardized around using Horde and Build Graph for all of our builds. Horde is a software that is a complete automation solution that is built and released by Epic. But we've done some interesting Riot modifications to it in our deployments. We have added additional output processing that allows us to ignore or ban specific output patterns. We have added support in the Horde JSON config for JSON token replacement, which allows us to create a Horde config once globally in Core SDK, and then for each game team, using the token replacement functionality, that config can then be configured to the team-specific Horde deployment specs. And we have done some auto-scaling changes as well. In Core SDK, we actually instantiate a Horde build system per game team. This is done through Terraform and infrastructure as code techniques. And as you know, one of the big advantages about Horde is that it's parallel by default when used together with Build Graph. So in the next slide, I'm going to cover a couple of examples of Build Graphs. One thing I wanted to mention is we actually had another talk around how we switched from the previous CI system that we had to Horde, and this was given at Unreal Fest Gold Coast in 2024, so you can catch up on that if you're interested. In terms of shared build graphs, these are all shared inside the Core SDK folder. If you look on the diagram on the right here, there's the Core SDK build. You probably will remember that Core SDK folder from the shared standardized directory structure that I covered earlier in the talk. And so these build graphs all ship as part of this Core SDK release folder. The build graph that we share and launch and ship this way are all the build graphs that are meant to attack kind of game agnostic problems, like for common build operations, like build, cooking, packaging the game, localization, publishing, promotion, test automation, etc. These build graphs are written in a way to be as generic as possible so that they can then be configured depending on what the game team wants, for instance, what platforms they're targeting, based on their team and project-specific config that I mentioned before. Also, we don't stop game teams from adding their own build graphs to their own depot, of course, and this can be useful for team-specialized jobs or game-specialized jobs that don't apply for the entirety of the ecosystem. One other interesting piece of infrastructure that we operate for all of our game teams is RoboMerge. This is another piece of software that is developed and released by Epic. We've done some Riot modifications to it, mainly minor in this case. But the interesting thing here is that we standardize around the best practices around how to use RoboMerge. This is used by all our game teams, including Unico, which is not a game team, it's a central tech team, but it's used by all our teams. And one of the things that we have standardized around is the best practices for release workflows in the Core SDK ecosystem, which kind of emulates the Fortnite-based chain of release streams that feed into one another, like that one on the right. But this is also used for other development workflows, especially for short-lived development branches. This is not really a piece of infrastructure, but it's a shared tool that Unico kind of builds and distributes to all of our game teams. Unreal Game Sync, it functions as the entry point into the ecosystem for us. It's, again, a tool that is developed and released by Epic, but we have done some pretty heavy Riot modifications to it. First of all, we have custom environment control integrated within UGS, which we call the environmentalist. This allows each game team to configure their own developers' environments to some extent. And yeah, it's how we control things like environment variables that we need and other aspects of the developer environment. Also, one interesting thing is that for our content creators, UGS is how they also get their pre-built, CI-built editor builds. And we have integrated with Riot's CDN and the patcher to distribute the editor builds, which allows us to distribute them faster than we would otherwise be able to our content creators. The way we ship UGS is also kind of interesting. We allow even though Unico builds and ships and releases UGS versions, we allow our game teams to select and configure which version of UGS they want to be on, so that they can control the timing of upgrade when it comes to UGS releases that we publish. This is because we don't want to, since we have a number of game teams, we don't want to ship a UGS version that may be destabilizing in the middle of a critical game team milestone. So this kind of level of control is necessary when you have multiple teams in different stages of development. Also, we have support for project-specific toggles in UGS that we use for some game-specific features. OK. Hopefully that gives you an idea of how the ecosystem functions. Let's talk about our development philosophy a little bit. First of all, let's talk about the Unico team itself. One of the basic pillars of the way we build shared ecosystem features is that we always want to build them with the game teams first. That is, we want to embed and solve the actual game problem before attempting to generalize the solution to the ecosystem and have other developers benefit from it. We don't want to develop core central ecosystem features in a vacuum. Ultimately, we want to intimately understand the game-specific issues and really be in the trenches with our developers. That means we want to establish as much as possible a deep partnership and integration with them. And we don't want to be a regular service provider, we don't want to have a regular service provider customer relationship with our teams. We are overall one company. It's all Riot. We don't have like thousands of games, so we should be able to achieve this kind of deep partnership. Also, in Unico, we always strive to converge and reconcile different approaches to the same problem. When you have multiple teams that are pushing as fast as possible towards their game deliverables, different solutions, or maybe similar but slightly different solutions to the same problem can emerge. And this is what we call the fragmentation of solutions in the ecosystem. This is not necessarily bad. In Unico, we never want to stand in the way of game teams making forward progress, but it's our mission to strive over time to reconcile and converge these solutions into one golden path solution that we can rubber stamp with this is the ecosystem approved solution, and it comes out of the box for all of our future game developers or future games that we might make at Riot. Ultimately, we want to be, Unico needs to be gatekeepers and owners of the ecosystem, and we must be opinionated for the strategic direction of the package. We must be vision holders for all the crucial components of the ecosystem. That being said, though, a lot of what makes the ecosystem good today was developed outside of Unico. This both from game teams and other central tech teams. And this open collaborative model of development has so far been instrumental to our success, which means that we want to keep our game teams and other teams empowered to change or add core SDK components. This is foundational for us. So how we do it is we have a set of expectations for what we call these contributions, which we call them upstream contributions. Multiple teams must have manifested interest in the shared features. New features should always be opt-in so that we're not sprung on live games. New features should always be easy to adopt and non-destabilizing. Ultimately, even with all these changes flowing into the ecosystem, Unico is still the gatekeeper for anything actually entering the ecosystem. So we're ultimately responsible for merging those contributions into the core SDK mainline. We also need to establish a clear ownership and support model for all the core SDK components. And as you can imagine, with all these contributions coming into the ecosystem, that can sometimes be difficult. It's ludicrous to think that the Unico team would be on a whim be able to become subject matter expert for anything that is flowing into the ecosystem, especially new whole features. So what we do instead, we have to establish different levels of SLAs and tiers of guarantees for our developers to know what kind of support they might expect for different kinds of components. In terms of guidelines that we give all of our developers contributing to the ecosystem, we give guidelines around due diligence, both in terms of socialization and tech design, so that we can review their designs. We give guidelines around coding standards and best practices for all developers to follow, regardless of what game they're working on. And we obviously give guidelines around the actual mechanics for the contributions. Speaking of mechanics, this is kind of a simplified diagram of how the upstream contributions flow into the system. So this is all inside our per4 deployments that I was talking about before. At the top, you have the core SDK depot, and at the bottom, you have two example game teams depots. What happens is that game team engineers or Unico engineers would perform these integrations, which we call upstream contributions, from a given game stream, for instance, their mainline in this case, into a game-specific upstream contribution stream that lives inside the core SDK depot. And then Unico engineers will be responsible for merging those contributions into the actual core SDK mainline, which means that they will eventually ship into an actual core SDK release. In terms of support, let's talk a little bit about support. So we have shared Slack channels that we use for support for game team asking for support and asking for help, and other teams as well asking for help about core SDK topics. And what we found is that in the shared Slack channels, we've seen game teams often help each other on problems, even without Unico interventions. So in our experience, support has also been collaborative. This is, we think, good because it helps create relationships and trust across the organization. However, ultimately, Unico is responsible for the support of the Core SDK ecosystem, and this is especially true for centrally owned critical components to the ecosystem itself. This means that the Unico team must have sufficient bandwidth to deliver on the predefined SLAs that we agreed upon. And we think this is important because overall, the game teams are moving according to kind of publishing needs. And they may ramp up or down. While Unico and Core SDK are kind of a long-term investment. And that's why we think it's so important to retain institutional knowledge of the critical components of Core SDK centrally. Ultimately, the way we achieve it, we think, is we need to separate the support bandwidth from the development bandwidth in Unico to be able to meet those SLAs with confidence and avoid what I like to call the emergent work death spiral, which is when support and emergent work kind of cannibalizes all of the development bandwidth of a central tech team like Unico. All right, let's do some conclusions then. In terms of what's been working well for us, we feel like we've had a pretty good impact at Riot, even though we are a very small team. We are only about 20 people, which is a small team by Riot standards. And all UE-based games at Riot are now rallying behind Core SDK. We had some good success in our core goal of sharing technology across games. We've established a lot of good golden paths, we feel. We have one way of interacting with Riot Online services in our real games. We have one way of doing performance analysis and monitoring, one way to implement audio, one way to do crash reporting, etc. And also another interesting thing is that lots of tech that was originally built by one game team for their game has now been adopted by many, which is great. So overall, we feel like we had some success in improving overall efficiency and reducing duplicated work across game development at Riot. However, Core SDK is still relatively young. We're only a couple years in. And there are some critical areas of AAA game development at Riot that we still don't cover with Core SDK Golden Path workflows. Our QA practices for Core SDK releases are still somewhat immature as well. I mentioned the problem of support work. We found that support work always wins. This can be a very heavy toll on a small central team like Unico. And as I said before, we think this must be addressed at the organizational level. This is because if a central team like Unico is fully cannibalized by support work, it can really stifle the core mission of being a multiplicative force for game development at Riot. Also, one thing to note is we have a moving target. So Epic keeps pushing out great Unreal Engine releases, and keeping up with Epic is definitely work. We also implement a number or integrate a number of third-party offerings in our shared ecosystem, and keeping up with those upgrades is also definitely work. And because Core SDK is a long-term investment, we really need to continuously audit all of our techniques and all our systems to make sure they are best in class for our developers to consume when building AAA games at Riot. On top of that, as you probably have seen by now, there is a lot of integration work happening within the ecosystem. There's a lot of integration happening from Epic. There's a lot of integration happening from other third-party offerings. There's a lot of integration happening from and to game teams, which is not very sexy. And I don't know very many developers that love integration work. So that's also a problem. In terms of where we're going, so we have a myriad of opportunities because the ecosystem is so young. First of all, we want to level up and improve build and developer efficiency overall for Core SDK developers out of the box. Epic has been focusing for a couple of years at this point on improving this for all Unreal Engine developers. What we want to do is we want to deploy all of Epic's best practices out of the box for all of our Core SDK games. We also want to invest in research in using Riot patching technology for additional efficiency wins on top of those Epic best practices. We also want to improve our test automation overall across Core SDK games. We do test automation today, but it's somewhat limited. And what we would like to do is we would like to create a shared device farm for all of our Core SDK developers to enjoy and perform on-device test automation like very trivially. And this is both for functional testing and performance testing. We also want to have out-of-the-box supporting Core SDK for complicated end-to-end multi-client tests, which is something we've been working on for a bit. In terms of tech sharing, as you probably have seen by now, there's a lot of tech sharing happening within the ecosystem already. But because of this integration overhead, what we want to do is we want to build more tooling for assisted and automated integrations. And we also want to overall ease in adopting Core SDK technologies, especially plugins, across Core SDK versions, which is something that sometimes has bitten us. Last but not least, we want to create a configurable template for a new R&D games. So at the moment, when a new R&D effort starts at Riot, basically what they get is they get effectively the whole plethora of Core SDK plugins and technologies, but an empty Unreal project. So the first thing they have to do is kind of like to get to a playable Riot multiplayer type looking game, they have to enable a bunch of plugins and configure them. Instead, what we would like to do is we would like to have like a configurable template that comes with all this technology pre-configured already out of the box. This is in order to kickstart new games. And these are just four kind of areas that are the ones that excite me the most, but we have a lot of other things in our mind. All right, thank you. And we should have a few minutes for questions. Before we go to questions, one thing I want to mention.
Well, hello. Hi, everybody. I'm Sam. I'm a technical designer here at Epic Games, and I'm here to talk to you about the Unreal Editor for Fortnite. Well, more specifically, what I'm here to do is talk to you about making deeper, more complex, more interesting, advanced games in UEFN using Unreal's tech, Fortnite's backend, UEFN's tooling, and a little bit of Verse to tie it all together. And so let's get into it, because what I've been doing all year is been making games. I figured the best way to demo UEFN is to make a game. It's a game-making tool. So before we move to the latest hotness, I want to just walk you through the games I made this year to sort of show off what UEFN had to offer as it came online. So back at GDC in March, I made a top-down twin-stick shooter using our new camera, our new third-person controls, and scene graph prefab to build the environment. It's a classic maze shooter, but I added a lot of movement tech from modern games, sliding, mantling, that kind of stuff, and it produced something pretty neat. I was pretty proud of it. However, for Unreal Fest Prague, I wanted to really play to the strengths of UEFN. So I took that same top-down twin-stick movement shooter template and turned it into a 3v3 PvP game with objectives and controllable NPC AI, because I am an RTS designer at heart, and I'm going to put controllable NPC AI into anything you let me do. So that's this, and it was also pretty cool. And you may notice it had a lot more dynamic camera. There was a lot more going on there. And so where do you go from there? What is next? Well, the answer is to bring it all together. And by that, what I mean is I wanted to go back to the PvE design of my original idea, but as a multiplayer game. And I'm an RTS designer, so I wanted to roll in some tower defense concepts. But this is a sci-fi environment, so you're not defending a castle, you're defending a spaceship. And spaceships can move, and that's way more cool. So here's a quick little cut of the thing I built. We'll have a full playthrough at the end, but it's worth just kind of seeing the basics of it so you can understand the kind of game it is. The idea is that you have to get your spaceship from the start of the level to the end. You can start it and stop it, but it follows a linear path. You can capture NPC sidekicks to defend the spaceship, and you can also send them to protect yourself. And because it's a 3-player game, that gives you a lot of tactical options. Then we have multiple enemy AI types, including ones that self-destruct against the player. And if you pull it off, you escape and you win. Yay, lucky you. And so what went into this? It is a 3-player PvE tower defense game. It has dynamic sequencer-driven animation, custom camera and control. The play space was built with scene graph prefabs, has custom NPCs with unique non-Fortnite visuals and custom AI, has a custom UI, and it's all tied together with Verse. So before we get into real specifics, I do want to talk a little bit about just basic setup. I'm going to gloss over it, bear with me. But setting up this, first things to do, created the experience settings. Said this is a 3-player game. It is competitive, cooperative. It does not have rounds. All the basic experience setup. And then I use a class designer to set up my just custom player class. In fact, I can hop over and show you all that stuff. So I've got, these are all my Verse devices and my various UEFN devices, but I built that to get things going, a class designer. So our player was set up for top-down movement, high speed, and basically a third-person game and a top-down game don't play the same, so I wanted to make sure everything was set up correctly. However, I don't want to spend too much time on the basics. I want to get into our spaceship. So what I'm going to do is talk about how the spaceship works. So the spaceship is driven by a cinematic sequence device. So I have several. Let me drag this out a bit just so you can see what they're called. So a cinematic sequence device called Ship Move. And this is synced across the network. And all it does, if we go to the sequencer, come on, sequencer, you can do it. Where is, there we go, sequencer. So all it is an animation moving the ship from A to B. When you hit B, you win. If you blow up before you hit B, you lose. It's as simple as that. However, if I was to jump back to the slideshow for a second, you may remember that there was a lot more motion to the ship than just like a straight transform move. And that is because I'm using layered animation to bring it to life. What that means is I don't have one cinematic sequence device, I have multiples. And those ones are running cinematic sequences that use additive transform tracks. Sorry, long day. They use additive transform tracks, which means that rather than overwriting the transform in the animation, they add to the existing transform. So for instance, these ones of the ship stopping and starting, it's just pitching up or pitching down the ship in an additive way, so it's not resetting its location to the beginning, and it's not messing with its angle. I'm also firing off some VFX in the same cinematic. And then you can make it a little more complicated. So I have 2 damage states for the ship. And each of those is a looping additive animation that is adding basically a double pull-in noise to various axes and angles of motion in an additive way, so the ship starts rocking around. It's also triggering a bunch of VFX to fire in a loop, so it's always exploding. But it leads to this kind of wiggling, dynamic, like, oh no, our ship's in trouble effect, which I think is really pretty cool. And then the final thing that I use this cinematic sequences for are my dramatic endings. So ship escapes, which you might have seen. Ship blows up. Not so good. What I love is right there, you can actually see the ship blow up as the game ends. I spent a lot of time on that. And these are pretty simple. Victory is just a standard animation. I know where the ship's going to be at the end, so I animate it leaving. However, when it's destroyed, I need to use an additive animation because I want it to blow up and spiral into the stratosphere wherever it is, not at the beginning. So I use an additive animation for that as well. And one of the key things with all of these, including our sweeping intro sequence, is that none of them use cinematic cameras. They are all using the camera devices in UEFN, mostly the fixed angle camera, to create all these effects. And part of that is because I need the camera to go where the spaceship is, not where the player is. So let's talk about cameras for a little bit. So here in the editor, let's bring up one of my cameras. My camera devices. So you may notice I have a bunch of camera devices. And they are all doing very specific things. Now we have 3 cameras that are automatically added to every player on start. Apologies, 4 cameras. We have your default POV. It's your view of the world, top-down camera. Tried to arrange it for a kind of a 3/4 perspective. And then you have the intro camera, which you may have seen is that cool high-angle view. And you have the endgame cameras for defeat and for the ship escaping. In each case, they are just more fixed angle cameras. The only difference is defeat and escape. I have set to track, as I scroll down way too far, my ship, not the player, because I want it to pan over to the ship, because the ship is the focus of the game. You want to see it be destroyed. You don't want to just be like, I guess I lost, because that's not that much fun. So, and then we have the intro camera. And so one of the fun things with the intro cameras is the highest priority. And cameras have priority settings. And so when I activate it right at the end, it means that the last thing you see before the game ends is the high angle shot of the entire station again. It's a nice dramatic end after a dramatic intro. However, there's a little bit more than that, because I also have the dynamic game cameras. So I'm going to quickly show you a slide of those. So I have 3 heights of camera. That's the default, added to the player by default. And then I zoom in. And this is for interiors. And I zoom out when you're on the ship, so you see a little bit more of the play space. So how do these work? Well, it's actually pretty simple. Why is it not quitting my slideshow? There we go. So the way it works is these cameras outside the default are not added to the player on start. So you see zoom in, zoom out, not added to the player on start, but they're always enabled. They have their own priority settings so that they override the default camera. And what I do is I add them to the player situationally, meaning when you, if I bring up my thing and hide some of this so you can actually see it. So for these, I use mutator devices, the mutator zone device. What that is a device that tracks the player entering and exiting a trigger zone. It can be a circle or a square. And It tracks the player entering and leaving, and you can modify the statistics of the player while they're in there, which is not really what I needed them for, but it's still, useful to have. So what happens is when you run into one of these mutator zones, let me just select one, all I'm doing is going on player entering zone, I'm adding audio, and I'm adding the camera. Simple as that. I add the camera when you enter the mutator zone. When you exit, I leave. So let's see. Zoom in camera, if you look at the zoom in camera settings, all the way down here, it is add to player. On entering these areas, remove from player. On entering these areas. And then the one for the ship is exactly the same. It's just a mutator zone attached to the ship, so when the ship moves, it moves. The one difference is there, I've actually slowed down player movement because I don't want you to go flying off the ship when you jump on it. So that is what that is for. Now, there is one more camera you might have noticed in my little teaser. I'm going to remind you of it right now. So this is what I call my strategic camera, which is a orthographic projection as opposed to a lens simulation camera like these. This is an option we added to UEFN for cameras relatively recently. If you don't know what an orthographic projection is, it's not simulating a lens, it is doing math to basically draw 3D spaces 2D. So your lines are perfectly straight. It gives you a nice clear view of the play space. And how that works is a little different, because obviously I cannot go, oh, well, you've entered this area, so I'm going to bring up the strategic camera. That doesn't work. So instead, to get the SatCam to work, I use a little bit of Verse. So in Verse, I created a player manager device. And what that does, there's a lot of stuff in it, but for the moment, it takes an input trigger called strategic view. That input trigger, let me select it. Let's get the input trigger. So these are input triggers. What they do is they let you override inputs in the game, and you can consume them, which means that the original binding doesn't work, or you can let them be. I consume them. And so what here I did was I overrode what is the aim button in Fortnite, because in a top-down shooter you don't need to aim, and I turned that into my strategic view button. Hold it in, go into satellite view, release it, you go back. Which is all well and good, except the input trigger will be triggered by any player hitting the aim button, not just the player who did it. And it would be really annoying if you're playing the game and suddenly the camera zoomed out and turned gray on you when you didn't want it to. So for that, I set up the player manager to handle these input triggers. So for the strategic camera, it's actually really easy. All I'm doing is subscribing to their on-camera pressed and on-camera released events, because everything in UEFN is event-driven. I can take those events. One of the fun things in Verse is those events pass an agent. That's the person who actually hit the button. An agent can also be an NPC. NPCs can't hit buttons, so I know it's a player. And so what I do is I can then take that agent and only add the camera to the one who hit the button. The post effects are only added to that player. They only show up on their client. Same with, I changed the audio mix, I have some sound effects that I'm playing, a whole bunch of stuff. And then when you release, it's exactly the same. It's just inverted. So that means you get this cool orthographic camera with all of this nice transition. Like, I'm not doing this with sound, but yeah, the sound drops out, it becomes all satellite, the post effects come in. I have the wrong slide playing. Here is the correct slide. And as you can see, it's pretty effective, it looks really cool, and it's not very complicated to set up. Okay, so now we have, we have a beautiful camera setup. We have a player that we can control. We have a ship that moves. What we don't have is a world for it to move through, like this world. And this world was built with scene graph prefabs. So I'm going to give you a little demo of what those are. So while it's loading in, I'm going to talk about scene graph prefabs. You've probably heard a bunch about scene graph this Unreal Fest, but basically it allows us to use entities and arrange them in a hierarchy and get access to the entire world on an entity level. Entities exist above actors in the overall Unreal hierarchy. They're much more lightweight, but they can also be customized with components, which is really useful. So here, you see a bunch of assets from the Talisman demo. If you don't know what the Talisman demo is, it was an awesome demo. It's the MetaHuman downstairs. And if you want to use any of those assets, go to Fab, type in Talisman, audio, props, VFX. That's all I do. I just use their stuff because I'm not an artist, I'm a designer. But to make a scene graph prefab, you have this hierarchy of entities, which can be like static meshes, and then you save it out as a prefab that you can just drop anywhere in the world as an instance. And so what I did was basically turn a bunch of the props from Talisman into scene graph prefabs. So this is a scene graph prefab with a bunch of props in it. It is a series of entities with static mesh components, and that's basically it. That's all it needs to be. And so far, so Blueprint Actor, right? You know, you get stuff, you arrange it in a stack, you add components, you can place it anywhere in the world. And so I built all of these things as prefabs, but one of the fun things with prefabs is they're just entities, which means all of these are prefabs built from my other prefabs. You can stack them in a hierarchy. So for instance, one of these corridors is several floors, several walls, a couple pillars. They're all separate prefabs that have all been turned into one prefab that I can drop in the world. But because it's all inheritance-based, if I want to update the floor, I just go to the base floor and go, oh, wait, that's offset a little bit. Let's fix that. And it will fix it for everything that uses it. And that allows me to build out a tile set to build my world. So next, I'm going to open up the actual level design map where I built my world. And here we go. Here is the actual world. And you can see these are all prefabs. Look at that. That is a prefab, that is a prefab, that is a prefab. And all I did was drop them in the world and then lay them out how I wanted. So, and select all these different prefabs. However, there is a thing you should know. You could just copy paste them in this layout into a new map, but that's really messy. And there are more efficient ways to do things. So one of the fun things with the prefab, if you'll, let me just jump back here, is you can do a command called group under new entity with any prefab. And then once you've grouped it under a new entity, you can turn that into a new entity into a prefab asset. And what that means is if I jump over here, this is just a prefab. This is my entire layout as a single prefab. I'm going to open it up. Actually, that's the wrong one. That's the one that is multiple bits of prefab. Let's jump back. But yeah, it is one giant prefab. And that means when I come to lay out my level, let's go to the level design, go back to the main map. Come on, level design map. OK, let's go back to the main map. And I go to a top-down view. Once it loads in the interim, I will just vamp. But yeah, scene graph prefabs are really useful. They are an experimental feature. They're going to go beta, so you can publish them reasonably soon. But right now, they are experimental. If you want to enable them, you do it in project settings. In your project settings, which I failed to select. There you go. So your project settings are there. You would turn them on. So you can't currently publish with these, but you can soon. But if you look at the top of my map from a top-down view, it is literally two scene graph prefabs, one's flipped 180, and offset slightly to create my entire layout. That's it, plus some nifty VFX that I totally stole from the Talisman demo, as I did with this nifty planet. And that gets you the layout. Simple as that. And then, of course, this is the Unreal Engine. It has really powerful tech. So I went through, I propped it out primarily with Fortnite props, some fab props. We have a huge library of stuff in UEFN. I did some fun stuff with atmospherics and fog to create the interior spaces. The interior spaces also have their own post effects. All that kind of stuff to just really sell the space as a cool space station, not just a collection of tile pieces. And that got us the layout. And so now we have a layout. We have a ship that can move across the map. We have a player that can shoot and run around and do all that kind of stuff. And if we were to play the game, we just win because, you know, there's nothing to attack us. And so what I need to do is set up some NPCs. So I'm going to first show you what I needed to do for my enemy AI, is that I needed 3 kinds of AI. The slide says enemy AI, but the friendly AI is not too different to the range. So I needed self-destruct ones, so it would run at the ship and explode, damaging the ship. And I'll show you how I built that health bar later. And then ranged ones that act like just FPS enemies and harass the player. And then the player recruitable ones would be the equivalent of the ranged ones, but under player control. So my original goal for this was to just, let's use some AI stuff that I'd already done in previous projects, but it didn't really work. And I'll get into that more in a second, but what I want to show you now is how I got those things to spawn in the first place. So I used an NPC spawner device, and I can't spell, NPC spawner device for enemy spawners. And you can see I have ones for ranged, ones for self-destruct. And how are they showing up with my cute little robots? How does that all work? How do I have these custom NPCs? Well, NPC spawner device, unlike our other character spawners, like wildlife, guard, creature, all of that, those allow you to modify pre-existing archetypes a little bit, but ultimately are there to designed to spawn Fortnite enemies. But what you can do with an NPC character definition, like one of these, let me just dock this so you can see it a bit better. So NPC character definitions, you can open it up and basically define an entire character. So that includes the type. It has the guard and wildlife archetypes. I'm using the guard archetype simply because it's shooter AI. I need shooter AI. Why would I write that myself? But you could put wildlife or custom, meaning a verse behavior. If you want to write AI entirely in verse, you can. Verse behavior, right there. I didn't do that. And then what I did do is basically override almost every setting in that NPC. Because you can drop in modifiers on NPC character definition, awareness, guard perception, patrol path, all of that kind of stuff, and get them to behave how you want. Because ultimately, top-down shooter and a third-person shooter are not the same thing. You have way smaller field of view, but you can see behind you, or it's just a very different game. So I could not just use our default AI. However, the other thing I wanted was I wanted them to look different. You may notice in the video, they're adorable little robots. And that is not a standard Fortnite character. In NPC character definition, you can just apply a bunch of pre-selected Fortnite characters to it, and it will use those. But me, I wanted to use StackoBot. So if you don't know who StackoBot is, he is the star of a sample project that my team, the tech content team, put out a couple years ago. It's a third-person, non-violent platformer. And I decided to bring StackoBot over to UEFN and give him a gun. Because, that's what you do. So StackoBot became a TackoBot. And so I imported the skeletal mesh, because you can bring a skeletal mesh right in from UE to UEFN. I made 3 variants with the material. So golden one is DefenderBot. That's the one that you recruit. And then the other 2 are AttackerBot. And he's got crazy eyes. He is there to shoot you with ranged weapons. And then we have DestructorBot, who pulses, because that is the universal video game language for I am going to blow up. And that is my basic robots. However, if I was to plug them directly into my NPC character definition, and these are just blueprint actors with a skin, and that's all they are, they wouldn't work, because UEFN does not have an animation set for that character, and I'm using the guard logic. So I need the Fortnite animations to retarget to my character. And funnily enough, all you need to do is create an IK retargeter. And this is an IK retargeter. It is what it does is it lets you take a source skeleton, like this. This is standard UEFN mannequin. And then take the skeleton of your own choice, and then have it use IK to dynamically retarget the animations to the other skeleton. And because StackoBot isn't that different, it's another humanoid, its proportions are different, I basically just hit the automatically do this button a bunch of times, and it worked pretty well, because I got that. So if you can see that, they are both using the run animation. I've tweaked StackoBot settings a little bit, so it's not quite the same. I want them a little more cartoony, a little more fun. And then, with that done, All right, you open up your NPC character definition, and you go down and add a cosmetic modifier, custom character as opposed to an existing character, plug in your blueprint, retarget from Fortnite character, here's your retargeter, NPCs that use Fortnite animations but are entirely a skeletal mesh that I brought in. So you could bring in your own characters and have them animate, have them be enemies for the player without having to write your own AI and animation, which is really key in UEFN because you don't want to spend forever doing this. You want to get it stood up. Okay, so if I was to spawn these NPCs from NPC spawners, they'd spawn. It would be the same kind of spawning behavior we usually have, where they hang out at the area where they spawn and do the stuff that they do, which would be attack the player if they saw them. Though Destructobot has an attack range 0, because I'm doing some stuff with them. So Destructobot would just look confused. So what I needed to do was give them some actual logic, and that's where verse comes in. So what you'll see is these are all my NPC spawners. They're divided into waves. I'll get how the waves work in a little bit. But these are my NPC spawners, and each of them has a verse tag markup component that lists the kind of NPC spawner they are. So look at that, enemy spawner, self-destruct. And then I created a verse device called a friendly manager. And that, not friendly manager, because they ain't friendly, an enemy manager. We'll get to the friendly manager in a second. But yeah, so my enemy manager is one Fortnite device, verse device, sits in the world, and has a couple basic settings, a couple soft references. But what it uses is it uses those verse markup tags to get every spawner for self-destruct enemies and every spawner for ranged enemies. And then it puts them in an array, goes through the array, and subscribes to their unspawned and uneliminated events. Because every spawner tracks spawned and eliminated enemies that it spawns. Needless to say, this is very useful. So an uneliminated always calls the same thing. It's just removing the guard from the array that I'm storing it in. But unspawned, I am adding them to an array, so I know who my guards are. So I have an array of self-destruct bots, an array of ranged bots. And then let's talk about ranged first, because while self-destruct looks simple, it's actually more complicated. So all I do with a ranged bot is put them in an array, and then I call a function I wrote called findLeashablePlayer. What that does is it goes through the player array, randomly picks a player from that array, and assigns that to the ranged enemy. And it puts in a leash mode. And so leashing basically says you have to be between X and Y of either a location or an agent. Player's the agent, so they basically just chase the player across the map from then on. Really simple. When they're eliminated, they're removed from the array. That's about it. Not too fancy, but really useful if you just want people who attack the player without having to, have the player find them. And I think that's really key. However, you'll notice the self-destructs, all I'm doing in them is adding them to an array. So how do they self-destruct? Well, you see this. This is me spawning a suspended function, which means it has a pause in it. And so the suspended function is called chase ship. It is a loop. And it goes through the loop and then pauses. All the loop does is it tracks an object called ship tracking that I've put on the ship. I literally put a tracking device on the ship so it could be tracked because I'm that guy. And it gets its location, and then it has a follow distance, so it doesn't just all glom onto that one point. And I say that's where you're meant to go, and then I leash them to that location. If they can't find the tracking bot, I leash them to the player instead. This was because of a debug thing, I'll tell you in a sec. But that's all it really is. And then that loop runs every second or two and goes, hey, all of you, ship's there now, go there. That way, if you're moving the ship, they will chase it. It's pretty dynamic, it's very reactive, it's very fast. And it's just a nice, simple loop. However, I had a bug. All the way through this project, I had the gnarliest bug where, for whatever reason, my enemy NPCs that were self-destruct would not attack the player after halfway through the game. And I debugged on my verse. One of the reasons my verse is so pretty now is I went through making sure it was all to standard, couldn't fix it. It turned out the tracking device I put on the ship, because I'm cute, is a little satellite dish, because I thought that would be cute. It's a Fortnite prop. they're destructible. So halfway through my wild action, they'd blow up the tracking device and the game would break. This is why you debug your own work. It's good to do. But anyway, so that is how you get our two types of NPCs. I'm going to bring them up again just since I've talked about them so you can see that behavior. So self-destruct ones, running at the ship, blowing up, ranged ones surrounding the player, shooting them. Question though, how does the ship blow up? Because Destructobot is just running at it. So let's get into a little bit of that. So the ship, if you can, let me switch back to my ship. If I turn on game view, zoom in a little bit, it has a mutated device on it. It also has a damage zone on it. Let me find the damage zone so you can see it. Where is my damage zone? There we go, my damage volume. So what that does is it does damage to anything inside it, but you can filter by team. And so this ship, anything on the team of the Destructobot that hits the ship dies. It explodes. I gave it a big dramatic explosion, which gets you halfway there, right? However, how does the ship lose health? And this is where we get into the next device I built, the Gameplay Manager. So the Gameplay Manager is probably the most complex device here. And what it does is manage the core gameplay loop and the ship. So it's all relatively simple for the ship movement and stuff. That's just a switch you flip, pauses or unpauses the cinematic. And it tracks the end game states. So if the ship cinematic ends, it knows to activate the win state, all of that kind of stuff. But we need to track ship's health too, because it doesn't inherently have health. It's not an actor, a Fortnite character. It's just a blueprint mesh with a point light. So what I do is I have two entries that the player can set, or the user can set, ship health and potential per enemy ship damage, 101. So has 100 health by default, 1 damage by default. One thing I do is I actually scale that damage based on the player count if the user wants, because it can be more fun to have more damage if you have more players. It definitely makes the game less challenging. The other thing I'm doing is I'm doing a few things with the ship health to create ship damage state bounds after it loses 10% of its health. Damage state 1. Damage state 2 is at half health. So that we don't have to get to yet, but I will get to in a second. Just remember that as I move forward. So what happens when the damage volume gets fired? What happens is a routine called reduce ship health is called. And that's just a subscription to the damage zone's enemy destroyed event. That just calls this. So I have a variable to check if the ship is destroyed. If it's false, then I subtract ship health. I subtract the increment from the ship health, so the ship health reduces. I update the UI. So it's worth talking about the UI right now. This is Verse UI. This is entirely written in Verse. What I did was I created a canvas slot, and I created a health bar widget that's a slider. And then I basically added it to the slot, and then I added that to all the players, and thus you get that nifty bar. And so you can write a whole UI in Verse. I just wrote one thing. There's a lot of good examples of that on the Epic developer community if you're interested. But it's if you want to make your own UI, it is not that hard. But yeah, so I call an update UI that just reduces the number that's displayed on the slider. And then if the ship health is greater than 0, I call my cosmetic update case switcher, which is those boundaries I talked earlier about, like lose 10%, lose 50%. I basically go, okay, then I'm going to turn on a switch called damage state 1 with the player, because you have to tell which player flipped the switch. And then I increase the damage state, which is what the case switch uses, so next time it calls it, it'll check the next damage state bounce until you hit the max. And the reason I'm using a switch rather than just triggering the cinematic that is the damage state is this is a thing that I find very useful in UEFN in general. A switch is just a true-false bit flip in the form of a toggle, and it can be player interactable, but you can just make it an invisible thing that is in your world. So what I tend to do in Verse is use a switch that and the verse just flips the switch, and then all the events that happen after that are all on the switch, because that way I can add, remove things very easily without having to rebuild all my verse and everything. It just makes it more efficient, and also when you're debugging, you have less places to look to go, what's firing that event? But yes, that gets us the damage states. If the ship has, however, no health, or less than no health, then we set ship destroyed to true. It's a variable. And we call this destroy ship routine. And that triggers the endgame loss. It plays the cinematic. It does all of the various things. However, the endgame victory switch, which is activated by the cinematic of the ship moving completed, triggers the ship escape, and then you win. So that is the gameplay manager, but it is worth talking about how it manages player or ship health, because otherwise you can't have a game because your ship can't blow up. You'll just always win. That's not fun. So now I have enemy NPCs. However, if I was to play this now, I would just get my ass rocked, if you excuse my language, because one player, no sidekicks, or even if 3 players, no sidekicks, I'm just gonna lose. There's way too many enemies just charging at me. So I need friendly AI. Oops, that's from the beginning. I didn't mean to do that. It's all right, here we go. So from the current slide, this is the AI I built for my previous game, for the 3v3 game. And this was my first attempt at sort of RTS AI within a UEFN context. And here I used a flag. And when you hold the flag, they follow you, you drop it, they stay where the flag is. But in the context of this game, it was too slow, it was too fussy. The only bit that really worked was capturing it through proximity. You stand near it, timer counts down, you capture the thing. So I rethought the AI, because in that game, you needed a lot of options for where you could have it go, or if you wanted it to follow you. In this game, you either want it on you or on the ship. It needs to defend you, defend the ship. That's its 2 goals. So I wrote friendlier AI. And that has the same capture logic, though I do admit I rewrote it in verse. And then they have a guard toggle instead of a flag, which means literally I hit the toggle button, they guard the ship. I hit the toggle button, they guard me. That's it. And then this is for each player. So this counts for all the NPCs that they've captured and they control, which leads to, you know, a little bit of complexity, but it's worth talking about how all that works. So let's jump into my final verse device. Sorry, a lot of verse today, but it's pretty useful. And that is my friendly manager that I decided to show you earlier for no reason. So the friendly manager is also relatively complicated. The difference between it and the enemy manager is there is 1 per NPC spawner for friendly NPCs. And the reasoning for that is I need to manage the capture state, which is a timer, a mutator tracking your position. I also need to make sure that a second player entering doesn't disrupt the capture or give them the thing instead of you. A bunch of basic rules for that are here basically on agent enter. I set as a capturing agent, all of that. None of it's that complicated, but basically the idea is you stand near the thing, you capture it, a bunch of lights change color, and then it starts spawning NPCs. So this is the interesting part. I then disable all the capture logic. I set a player as the owning player. And then I use the player manager to update the NPC toggle settings. Because if the player has their setting as false and you capture something at true and it's set to true, you want that to be aligned with the player who captured it so it becomes false. So this calls this routine in the player manager called retrieve NPC state. In the player manager, all I'm really doing is I'm keeping there are up to 3 players in the game. They're in an array. I have an array of the NPC states that matches index values to the player. And all I do is go, this player has captured me, it passes the agent, it finds the index value for that player, finds their NPC state with that same index value and returns it, which means I can just set the variable through a function in another verse device directly, and it means that everything is synced. And at the same time, in the player manager, if you do the toggle, you also want them all to be synced. And the toggle, and I'm going to get into how the toggle works. The toggle is another input trigger. This one isn't press release. This is press to toggle. I replaced the build button because you're not building in this game. And so instead, what I have is an input trigger. And just like the other one, there is the issue, what if you hit toggle and you're accidentally controlling your friend's NPCs instead of yours? That would really suck. It's just bad game design. So what I do is I subscribe to the pressed event. And let's go down here to target switch. I get the player that hit that button, because I want to make sure I get the right player. And then I call this thing called update player values. That does a UI update. There is a UI element for each player that shows their current NPC state. That's the Sam Evangelists, robots are defending the ship thing that slides in. There is one per player. And then I update the spawners. And I contact all of the spawners, which just like the enemy spawners, I keep in an array, and I've just tagged them as friendly. I reach out to them and go, hey, this character is changing their NPC logic value to this. And they go, well, that character doesn't know me, so I'm ignoring it. Or they go, oh, that character owns me, so I'll update my value. And that means every time you press like the Y button on your joypad, it just does that. It goes, hey, are you owned by this player? Toggle your status. But how does the actual AI work? Well, let's go into that. This is kind of an advanced version of how the self-destruct AI works. This is another suspended loop, leash NPC loop, which the difference being that this one does not loop through a whole array. This is specific behavior for each NPC because I needed them to have a little more like individuality, if you were. So I do a bunch of stuff to get the player. I'm like, is this the owning I want the owning player of the thing. And then I get their position. And I calculate. But this only happens if that logic value is true. And then I just go, here's the position of the player, go there. However, if it's false, I go, is the ship tracking device valid? Useful thing to put in after you found out that it got blown up. If so, get its transform. And then do a little offset from that. I have a ship follow distance. I don't generally like people to cluster right around my target thing. And then I move them to the new position. And just like the other one, this is a loop. So all it's doing is going, hey, am I chasing the player? I'll move to the player. Hey, am I chasing the ship? I'll move to the ship. And so if I run that slide again, you'll see that behavior in action. So I captured it. There we go. It's captured it. There they are. And so now they're defending me. Toggle button. Now they're guarding the ship. Super easy, super simple to do, and very reactive. And that gets us kind of to the last key point of the project. Like we've got enemies, we've got friendlies, we've got a layout, we have a cool environment and art, we have a player that plays exactly how we want, we have a 3-player multiplayer code that works. So what's next? What's next is I show you a complete playthrough of the game with sound. And I will narrate it a little bit so you know what's going on, but I want you to kind of see how this plays out as a total thing. And also you can watch my terrible, terrible skills at the same time. So there's me capturing NPCs. You may recognize this video from a previous slide. I see enemies are coming, take one out, and then go activate the ship. That's just another switch. Activates the switch, I just activates the ship, I just have it hidden on the ship. And so there, me and my sidekicks, Ambivalent Steve and Jill Without a Jungle, are taking on the enemies. I did put a creature spawner in there just for fun, just to surprise the player. But as you can see, I'm running off, going and recruiting more NPCs. They're flooding back to the ship, so it has a little more defense. The more NPCs there are on your ship, the better defended it is. I closed the ship down for a second so we can deal with all these ones running at us without just driving right into them. And then I want to work out what's going on next. And then, wow, Ambivalent Steve really is not doing a good job. So there's me running off because I've realized we need more sidekicks. And I'm running down, I'm going to find a spawner. I'm entering an interior space. You can see the camera moved in, the post effects changed. I actually changed the music when you enter an interior space. And also, by the way, most of the music is patchwork. I didn't really do a patchwork demo in this talk. Oh, that was where an explosion knocked me off my ship and landed me on the platform, which was pretty awesome. But yeah, this is all patchwork music that responds dynamically to how do you play as it builds up. And you can see all of the enemies coming in to get me. One interesting thing is I actually have waves here, and those are switches. Those switches are activated and deactivated by the actual animation for the ship. As it hits certain points, it calls a switch called Progress 1, Progress 2, Progress 3. What that let me do is turn on or off enemy spawners to create waves and to create a greater sense of, believability in the space. And I win. I escaped. My ship escaped. Dramatic ending. And so at this point, that is the talk, but thank you. But since we have a bit of extra time, I am more than happy to take questions if we have questions. Good, we have questions, otherwise this could get really awkward.
It seems